session today of Code with Claude. I hope you've all had a fantastic day so far. My name is Margot van Laar. I am an applied AI engineer at Anthropic here in London. And this afternoon, we're going to be talking about the prompting playbook. And prompting is arguably one of the first skills, if not the first skill, that we had to learn as engineers when we first started to work with LLMs. And even now, it continues to be one of the most critical skills to building effective AI systems. So today, we're going to discuss some best practices in the context of two practical scenarios that you're probably encountering at work. The first is where you have an existing prompt in production that you've been maintaining for some time, and possibly you're migrating it to a new model or making a change to the architecture, and for some reason, it's no longer working as well. The second scenario is where we're building an entirely new agentic use case from the ground up, and we need to build the prompt from 0 to 1. Now, in order to illustrate these best practices, I don't just want to give you a list of do's and don'ts. I want to walk through a practical example that's been inspired by real prompts that I've seen some of our customers work with who are building on Claude. So the prompt that we'll look at today is a miniaturized example. The prompts that you're working with are probably a lot longer and more complex than the one we'll see today, but it's representative of some common problems that you might encounter when maintaining a prompt. So imagine that we have a prompt that multiple people have been collaborating on, contributing to. There's no clear owner. It covers a lot of different areas like policy, like tone, processes, and we have some patches for kind of previous models that we've migrated to, all mixed together. It's built up and it's complex. And when we're migrating to a new model, we're finding that suddenly a lot of our test cases are no longer working as well as we expected. So what's actually going on here? Well, in order to start unpacking that question, we need a starting point, and that starting point is evaluations. We need evaluations to provide that rigor to understand whether a change to our prompt is actually correlating to an improvement in its performance. And we have different models which have different capabilities and different behaviors. And when you migrate to a different model, it could be that your system is no longer working as well for two reasons. First of all, if the new model might be capable, but it's behaving differently, and therefore we can tune our prompting to fix that behavior. The second case is where actually the model that we're changing to isn't as capable, and no amount of prompting is going to fix that. So we need to have an eval suite to act as a way of testing that regression so that we can apply our prompting best practices to that. So in the example that we're going to be looking at today, as I said, it's going to be a miniaturized example. We'll have 5 test cases in our eval. In reality, you'll have a lot more test cases in your eval suite, but the key thing here is that it's representative of 3 key cases that we need to cover. Those 3 key cases include having a control case, which is a case which should always pass. It's something that we know the model handles well. It's unambiguous. The second is edge cases, and these are cases where we've seen the model fail before. And by including instructions into the prompt, we're making sure that same behavior doesn't slip through again in the future. And finally, and critically, we need to make sure that the model has a good understanding of the extent of its capabilities, where it should be handing off to a human, or where actually maybe it should be point blank refusing to answer a request. So in the example that we're going to be looking at today, we'll be using a prompt for a customer support bot for a telco company called Meridian Mobile. And these are the 5 test cases that we are going to be looking at today. We have a simple control case looking at what's the data limit in the basic plan. We're also looking at edge cases, such as its ability to do calculations, such as calculating proration bills. If I switch my bill halfway through the month, or if I switch my plan halfway through the month, what will my bill look like? We want to check that it's accurately addressing key questions which are covered by our policy. We need to make sure that it's escalating to a human whenever there is a billing error. And finally, we want to make sure that our model isn't withholding any information that it has access to, which it should be handing over to the customer. So what we're going to do in this process is we'll take our prompt and we'll run it on our V0 of the eval. And we'll see what our failure modes are and systematically target those failure modes one at a time to see if we can resolve those failure modes by prompting. And along the way, we'll learn a little bit more about the kind of anti-patterns and traps to avoid. And this is representative of how we would apply these best prompting techniques in practice, right? We are rarely writing a prompt from scratch. We're often debugging an existing prompt. And best practice before we start targeting those failure modes specifically is to kind of apply our general prompting 101 best practices, applying general hygiene to clean up before we do the eval run. So let's have a little look at the example that we're going to be using. So what we're looking at here, first of all, before we look at the prompt, is just this vibe-coded web app that I've made for the presentation today so that we can look at how we're iterating on the prompt together. In this page here, I can easily run my evals on all 5 test cases and inspect the results in a little bit more detail. So before we have a look at the prompt, I'm just going to run the evals in the background. This is a pretty good first pass at a prompt. When we look at this, we've defined the bot's role at the top. When we scroll down, we've given it some data. We've given it some information on how to reason over the answers that it should be giving to the customer. It's giving some critical instructions around the tone it should use, how to do calculations, etc. And then finally, we're passing in our customer account context and our user message. So let's have a look at how our first pass at the evals did. So we can see, as we expect, our control case, all of our test cases have passed. This is what we expect for this unambiguous test case. But it's performing pretty poorly in these other areas. Now, before we zoom in on those specific failure modes here, let's do some general cleanup of our prompt. So as we mentioned, when we look through this prompt, there's a couple oddities here already. So for example, the first one is we're telling the bot that it's a human, which just isn't true, right? We can see as we scroll down, there's clearly some information here that has been copied directly from a website. So the key giveaway here is a reference to a hero image. There's even some references to cookies at the bottom. So we need to remove a bit of redundant information. When we look at the instructions here, they're all grouped into one big paragraph. So we've got some reasoning here, we've got instructions about the role, some critical instructions as well, without a real way of unpacking policy from guidelines, from tone, etc. So let me just... I've preempted some changes we want to make to this prompt, and this is just a diff view of some of those changes. So what we've done is, first of all, added some structure. So you can see that we've added XML tags here to define the role, to separate general guidelines, to separate policy, to separate tone of voice, etc. So if we run that eval then on this new updated prompt, we should hopefully see an improvement in the output as is. So we can see just by clearing up the prompt, we've already improved the model's performance on this prepaid scenario. There's an interesting regression there in that fifth hotspot case, and I don't want to worry too much about that now. There's going to be some natural level of variance in the different runs of the eval, and we'll come back to that case specifically to see if we can make the prompt consistently better in that area. So what did we learn from this then? Simply clearing up the prompt with a better structure, with a better role description, has improved the performance. And this is a best practice that you can return to at any stage of writing and maintaining your prompts, especially as your prompts get more detailed and more complex. A general rule of thumb that I like to follow is if you're reading a prompt and you can't tell guidelines from policy, from data, most likely the model isn't able to either. So before looking at some of those cases in more detail, there's a little bit more general cleanup we can do, specifically here looking at creating an output contract. This is a key best practice to follow if you're struggling with your output format consistency. Now, in this case, we have a customer support bot. We want it to reply in a conversational tone, so it's unlikely to be a big issue in this case, but it's something to bear in mind if you're dealing with more complex output structures like nested JSONs, for example. So again, if we go back to the prompt and see what fixes we can apply here, first of all, we've added a section at the end where we've defined an output format for the model, telling it to use XML tags to output the response. But the prompt is not always the most effective way of handling issues. We can also change things in the harness to ensure consistency to a higher degree. So what we've added here to the API call is a stop sequence, which is going to detect that closing XML tag and tell the model to stop generating a response at that point. Now, when I run the eval here, I don't necessarily expect to see any clear improvement in performance, but it's a general best practice that we should be following, and as I said, is something that we should remember, in particular when we have more complex output schemas. One thing to point out here as well, if you do have a more complex output schema, something like structured outputs can be incredibly helpful to ensure that consistency in a more programmatic way. OK, so after the cleanup then, we can see that we now have 2 test cases which are consistently passing, but we have 3 key failure modes: the proration, the billing error, and the hotspot. So let's isolate these one by one to iterate on the prompt and see the effect of that. First of all, then, the hotspot question. So the question is, how much hotspot data is on my unlimited plan? What we expect the model to do is state directly the amount of hotspot data that the customer has. And the reason this is a slightly complex case is because the customer test case that we're dealing with is on a legacy plan. So actually, the current policy doesn't apply to them. So if we see what's going on in the actual test case here, the customer data which we're feeding to the prompt includes the amount of hotspot data that customer has. They have 5 gigabytes, right? But they also have a grandfathered plan. So what we're seeing the model is actually telling the customer is the general, the unlimited plan includes 4 gigabytes, but since you're on a legacy plan, you should go check this out yourself. So let's have a look at the prompt then to see why the model is deflecting this question to the customer account URL rather than actually giving the information itself. Now, if we read this prompt, originally it said, we changed our plans recently, and the policy doc shows the current plan data and customers on grandfather's plan have different rates. Never give a customer the wrong plan details. Instead, point them to the URL. So it's clear that this instruction, this latter one, never give customer the wrong information, is the instruction that the bot has been optimizing for. And you might recognize this as being very similar to a patch that you might have introduced in a previous model that you were using to avoid, where the model was giving the customer the wrong information about their plan. Now, as our models have evolved, they have gotten much better at instruction following. So it's likely that instructions like these have now become redundant and are actually being overfitted to. So what we're going to tell the model instead is give this balanced view where it says, customers on grandfather's plan have different allowances, but it's captured in the customer information that's given, and that is the accurate source of truth. So running the eval here, we should hopefully be addressing all of the test cases for the hotspot case. Now, I am running this live, so there could be some variability here, but we see here that now clearly all of our test cases are passing. So what did we learn from this? Well, we worry a lot about hallucinations or the invention of facts and numbers, but actually the opposite can also happen. The model can withhold information that it actually has access to. Now, we saw here that this is likely a result of a patch that we introduced for a previous model, and a best practice that we could follow here is actually using version control, where wherever we are making defensive changes in the prompt, we are tracking the reason why we've introduced these. Sometimes they're necessary, but in the future, these kind of changes can produce unwanted effects so that we can backtrack on them. So the next failing test case then is this proration calculation, where a customer asks, what if I upgrade to the 30 gigabyte plan? What will my next bill be? And what we want the model to do is to perform some calculation and return exactly what their next bill would be, rather than giving some sort of vague output, which is what we can see it's doing right now. If we look at what the model is returning, it's clearly reasoning through it. It's doing a little bit of mental maths here and there, but it's not really giving the customer a concrete answer, and I wouldn't rely on this as being able to accurately give the customer a response. So if we look at the prompt then to see how we can fix this, in the original prompt, we can see that all the instructions that were given to it is telling it, don't ever give a customer a vague answer. Critical, always calculate any prorated amounts correctly. Now, telling the model to do a good job isn't particularly helpful when we don't give the model the capability to actually do a good job. We want to avoid the model doing mental math. So what we're going to introduce is give the model a tool. So we're saying in the prompt, whenever you're doing any calculations, please use the calculate proration tool to do so. In order to introduce that tool, we need to introduce it into the API to tell the model you have access to this tool. We need to define the tool schema, which tells the model what this tool does and when to use it. And then finally, we need to actually implement the tool, which is the maths behind how it should be doing that calculation. So running that eval then for another pass. We can see that all the test cases are now passing. It's clearly done the maths using the tool in the background and returning the correct response. So the key lesson to take away here is instructions don't add capability. Telling the model it's critical to do a calculation right doesn't make it better at mental math. So the correct approach was to give it a tool, overall giving it the ability to reason over harder problems and using tools to actually execute them reliably. So now we have one final failing test case which we need to address, which is this billing error here. In this scenario, there is a billing conflict, and what we really want is the agent to escalate this to a human. And what we're seeing it doing instead is it's trying to explain to the customer what the reason behind it might be, and it's trying to kind of diagnose the problem itself. So in order to fix this behavior, let's again have a look what it was told in the prompt. We see in the initial instructions it was giving, it says, avoid escalating or transferring to a care specialist unless absolutely necessary, as it cost approximately $8 and it counts against our team's fast contract resolution. Now, this is only giving one side of the story, right? We're telling it what the cost is to escalating, but not the benefit, which means it's going to overfit again to not escalating this scenario. And second of all, we've got this clear conflict between what we've defined in the eval in terms of what we want the model to do this escalation versus what we're actually telling it to do. And the fix that's relevant here is to give it both sides of the story by saying it costs $8 to escalate a case, but actually, if you get this wrong, then it's going to cost you a refund as well as customer trust. Again, here we observed how the model optimizes for a goal, and this kind of instruction is a common instruction to give. It's quite similar to the one we saw earlier, where we didn't want it to overfit to a certain type of behavior. But it's the kind of instruction that can be followed quite differently by different generations of models. And specifically, as models become more intelligent, we need to remember to state both sides of the trade-offs, because our models are becoming better themselves at making those trade-offs themselves. So if we just go back to our eval then and run our final test case, we should see that all of our evals are now passing correctly. So overall, we looked at applying general hygiene principles, how that can provide an initial uplift to the prompt, making sure we're removing any redundant instructions which were initially intended as patches for previous models' behavior, making sure we're giving it tools to do certain tasks reliably. Now, there's one other scenario that we introduced at the start, which is one that you might also encounter in your work, which is where we're building a new agent from scratch. And the example that we'll look at here is an agent whose purpose it is to create a week-long retail staff schedule based on employee availability and other constraints. And when we're building a new agent from scratch, we need to consider not just the prompt, but also the model that we're using and the harness that we're using. So in this next example, we're going to compare a number of approaches to explore the impact of those three different areas. So again, I've just vibe-coded up this web app so that we can walk through this problem in this demo. Here I've just laid out what the problem is that we're addressing. We have our 8 employees. On the right, we have this schedule that we need to staff with the headcount, and we have our constraints that must be satisfied in every scenario. Now, because we have these hard rules, rather than using an LLM judge like we did in the previous case to do the grading, we can actually use just a Python function which programmatically checks for every schedule that's generated how many violations were made. So to begin with, we want to start simple. We're going to use a simple prompt. We're going to use the bare bones that we think we'll need with a model, Sonnet 4.6, to see how it performs and how we're going to hill climb against that. So here is our baseline prompt. We've already applied some of that general hygiene and those best practices that we saw earlier on, using XML tags to structure the prompts. We've given it an output format as well. Now that we're giving a schedule, we're asking it to output a JSON, which, if we don't give that output structure, might lead to parsing errors downstream. When we run the simple model on a first iteration of the evals, all cases fail. Now, just what we're looking at here is in our test set, we're essentially repeating, we're doing 5 trials here, and these numbers are showing how many violations were made in each trial. In the outputs, we can see that it's made a decent attempt at reasoning through the problem, but it's burning a lot of tokens, and it's clearly not checking its work as it's not getting to the right impact. So let's try a larger model, a model which we know is better at reasoning. So we're going to run it through Opus 4.7 instead, keeping everything else the same. Now, interestingly, whilst all test cases are still failing, you can see that the overall number of violations that Opus has made has reduced significantly from Sonnet 4.6. So we're possibly onto something here, right? This isn't good enough to ship because it's still failing, but clearly giving it more reasoning capability is helping drive it towards a better result. So what we're going to try next is using Opus with adaptive thinking instead. So it can decide for itself how much thinking it needs, how much reasoning it needs to use to solve this issue. So no change to the prompt, really just a change to the API here. So this now seems to reliably generate compliance schedules, but it requires a lot more tokens. We're tripling, essentially, in the number of tokens that we're using here, and we're tripling the latency. So we want to try and see if we can optimize that cost-latency trade-off a little bit more. This is latency 100 seconds. Obviously, I'm running this one async for the purposes of time. Opus 4.7 hasn't magically gotten much faster since the last time you used it. So let's see if we can optimize a little bit more for the token latency trade-off. What we haven't tried yet is using Sonnet 4.6, so a smaller model, but with a better prompt. We looked a lot at the prompt optimization in that last section. So I've added a couple details to the prompt here. We're in particular how to reason through this problem, and most critically, telling it to check its work before outputting it. So when I ran that eval, we see that it passes in 2 out of the 5 cases. Now, the failure modes that we're seeing is actually not violations of the scheduling requirements, but the model hasn't been able to finish the tasks within the output limit that we set. So whilst we could increase the max tokens that this model is able to use to get all 5 test cases passing, we see here that we're using even more tokens, and this run has an even higher latency. So this is probably not the route that we want to go down. Now, as a final pass then, we want to look at doing this a little bit more agentically. So we're going to use this generate, evaluate, repair loop, where essentially the generator now creates a first draft of the schedule. And then we have a separate prompt which reports any specific violations that it made. So not programmatically checking it, but checking it with an LLM. So we're checking for every rule, and we're providing evidence of every violation. And we then have a third repair prompt, which receives any violations that were made and tries to make targeted fixes to it. So we have 3 very simple prompts, but they're now running independently rather than trying to do everything in one large prompt. So we can see in this case our agentic approach has solved all of our test cases with a much lower number of tokens and with a lower latency than trying Sonnet 4.6 with a better prompt. So going forward, it seems like there's 2 appropriate approaches to take here. Using Opus 4.7 with adaptive thinking or using this agentic loop. Now, moving forward, we'd probably want to do a little bit more optimization on this loop to try and get it to be more efficient. But there's one key benefit as well from using this generate, evaluate, repair loop. And that is that you can put in soft requirements at runtime. So in the evaluation prompt, we can say, Harry doesn't like working with Sally, so as much as possible, try and separate them from working together. Or we need a third shift on Wednesday, for example. So it means that you're not having to make changes to the Python function, which is doing the evaluation in the back end every time to satisfy for any soft constraints, which might depend just on a case-by-case basis. So to wrap up then, pulling all of those learnings together, what did we see? Well, we looked at 2 scenarios which I as an engineer see most in my day-to-day, which is where we're maintaining a prompt, we're migrating to a new model which has some different behaviors, and building a new use case from scratch. We saw that general hygiene principles, following those can immediately uplift the performance against a set of evals, and that we need those evals to be able to rigorously see any impacts of changing our prompt on the output. Then we saw this process of targeting failure modes one by one, adding structure, avoiding long ban lists, etc., were all things that helped push our model to the correct behavior. And then finally, with our new agentic bot that we were building, we saw the impact of splitting into 3 separate prompt systems. So rather than using one prompt to address everything, we're actually isolating different tasks where it's easy and repeatable to separate out the steps that it needs to take every time. Thank you so much for attending this afternoon. I hope you have a fantastic rest of your day.
Tell it the situation and be like, hey, can you fix this for me? It's incredible. Now, let's talk about best practices. And the first one is not going to be a surprise, but the first one is use Claude.md files. So remember that Claude Code, like I said, is an agent, and it has some tools. It has some lightweight instructions in the prompt, but it doesn't really have memory. And so the main way we share state across kind of sessions or across our team when we fire up Claude Code in the same code base over and over again is this Claude.md file. So when we start Claude, what happens is if there's this Claude.md file in the working directory, it's just plopped into context. It's plopped into the prompt. And basically what it says is, hey, Claude, by the way, these are important instructions the developer left for you. Be sure to pay close attention to this. And there's various places you can put the Claude.md file. You can put it in a project and check it in so all your teammates share it. You could put one in your home directory if there's things you just want Claude to always know about, regardless of what you're working on. And the things you put in here are things like, hey, by the way, maybe this is how you run the unit tests. Or just so you know, to make kind of your searching and life easier, here's just like an overview of kind of how this project is laid out, where the tests live, what different modules are, things like that. Or here's our style guide, all sorts of things like that to just make Claude's life a bit easier. And you can build these things up over time. The other thing you can do, which is important, is permission management. When you're running Claude Code, there's all sorts of different kind of permission things flying by. Kind of out of the box, what happens when you start our tool is for read actions. If Claude is searching or reading, we just let it go. But once it starts writing or running bash commands or doing things that could change stuff on your machine potentially, that's when we kick in this UI and it says something like, yes, always allow this, or no, I want to do something else. And using that permission management and being smart about it can help you work faster. So there's something called auto accept mode, where if you're working with Claude Code and you press Shift Tab, Claude will just start working. There's things you can do, like you can configure Claude in the settings where specific commands, like on bash, like if you just are like tired of saying, yes, run npm run test, you can just always approve that. So fiddling with your permission management is a great way to kind of speed up your workflow. Integration setup. So one thing that is going to help you get the most out of Claude Code is remember that it's great at the terminal. And if there's applications that you use which have kind of a way to access them through CLI, and GitHub is a great example of that, they have a powerful tool called GH, you can basically give more work to Claude Code. And you can do that either by just installing more CLI tools, or you can attach more MCP servers. I would say, just through experience, that if you're using something like a CLI tool that's well known and well documented, and you're trying to choose between the CLI tool and just installing it on your machine and grabbing an MCP server, I would recommend using the CLI tool. And then also, if you internally have your own tools, at Anthropic, we have something called Koo that does a whole bunch of stuff for us. You can also tell Claude about that, and that's the sort of thing you'd put in Claude.md. And then context management. So remember that Claude is an agent, and when it's what it does, it calls these tools, and the context builds up and up over time. And at least for Anthropic, our models have a context window of 200,000 tokens, and you can max this thing out. So you kind of have two options when you're in a long session with Claude and you're working and you're going back and forth. You'll see in the bottom right, you'll start to get this little warning that'll say, hey, you're starting to fill up the context window. And kind of depending on what's going on, you have two options. You can run /clear and just start over, and that clears everything out, except for instance, Claude.md. Or you can run /compact, and what'll happen is basically it's like a user message is inserted, and it just says something like, hey, I need to go summarize everything we've been up to. I'm going to give this to another developer, and they're going to pick up where I left off. And then that summary is what kind of seeds the next session, and you can go from there. We spend a lot of time tuning this kind of compact functionality so that as you max out the context window and then run compact, you can start back over and keep going. Efficient workflows. What can you do with Claude Code? And how do you get the most out of it? So using planning and to-dos, I talked a little bit about this before, but one of the best things you can do is when you open up Claude Code, instead of saying, hey, I need you to fix this bug, you can say, hey, I have this bug. Can you search around, figure out what's causing it, and just like tell me a plan how we're going to fix it? And this can save you a lot of time because you can verify, you can read Claude's plan, and you can verify what it's going to do. And then the other thing that we have is we have this to-do list feature. So often when Claude's working on a big task, it'll create a to-do list. And if you're kind of paying attention, you can kind of watch this to-do list. And if you see anything kind of weirder in there or something that doesn't make sense, that's when you can press escape and say, hey, Claude, let's change the to-do list. I think you're on the wrong path. Smart vibe coding. So it's very tempting and it's very powerful to just let Claude work and press enter and see what happens at the end. I think there's a few things that can help make this better, and there's, I think, a talk later today about just this for 30 minutes. But doing things like having test-driven development, having Claude make small changes, run the tests, make sure they pass, always having Claude do things like check the TypeScript and the linting, and then commit regularly so that if it's kind of going off the rails, you can always fall back and try again. You can use screenshots to guide and debug. So Claude is built on top of our models, which are multimodal. You can always just grab a screenshot, paste it in, or if you have a file somewhere that's an image, you can just say, hey, Claude, look at this mock.png, and then build the website for me, or whatever. And then advanced techniques. So as you're getting used to using Claude, what are some things you can think about to kind of push things to the next level? And one of the things we see, both internally and with customers, is when you've started to use this tool for a while, it's going to be very tempting to use multiple Claudes at once. And so I know people at Anthropic and a few customers that run 4 Claudes at the same time. There's various ways to do this. You can have it in tmux or just different tabs, all sorts of crazy things. So I would challenge you to try getting multiple Claudes running at once and kind of be orchestrating all these things. It's quite fun. I can only do 2, but I know people that do 4. Use Escape. So Escape is your best friend. While Claude is working, you can kind of keep an eye on what it's up to, and you can press Escape to stop it and interject and say, hey, I think you're going on the wrong path, or I want you to do something else. Knowing when the right time to press Escape is versus just letting Claude figure it out is key to getting the most out of the tool. And there's a hidden feature, not too many people know about it, but if you press Escape twice, you can actually jump back in your conversation. You can go back and you can kind of reset. Tool expansion and MCP. So this is taking it to the next level. If you feel like with Bash and with the tools that Claude has that it still can't do something, this is when you should start looking at MCP servers. And then headless automation. I think this is a thing we're most excited about, but also we are still trying to wrap our heads around internally, which is how can we use Claude programmatically? We have that in GitHub Actions. We want to figure out other creative places we can start using it. And I would challenge you all to do the same. So with that said, I'm going to jump over to my computer because there's one other best practice, which is it's always good to stay on top of everything that's new. So we're shipping super fast. I'm just going to go over a few things that are new as of today. One thing is when you're in Claude now and you fire it up, you can do /model. You can see what model you're running on. I'm on default, which happens to be Sonnet. We can jump over to Opus. You can do the same thing in /config. Switch it here. So that's new. Make sure you're running the model that works for you. There's another thing that's new about these models, which is you can say something like, can you figure out what's in this project? And for a while, we've had this like think hard or extended thinking. Now, this is great, but with our past models, we wouldn't let our model think between tool calls, and that's probably when the thinking matters most. So starting with Claude 4, our models now think between tool calls, and we can watch this happen. So we have Claude in this project. There's a few different files in here, and I'm just going to tell it to think hard and figure out what's in this project. And we can watch Claude start to work. And so the way you know you triggered thinking is you'll see kind of this lighter gray text, and then it'll call some file, it'll call some tools, it'll read some stuff, and then we see some more thinking. And this is awesome. So I encourage you when you're working on tasks and solving bugs, throw a think hard in there. And then the other thing, and you know what? We'll just throw it up real quick, is I have this in VS Code, but of course this is in JetBrains as well. But we have these new great integrations with VS Code and JetBrains. We can do things like Claude's going to know what file I'm in, what file am I in. That is not what I meant to say, but Claude's going to figure it out. And you can do things like this. So these are the sort of things I would encourage you to stay on top of. We have a public kind of GitHub project called Claude Code under Anthropic. You can post issues there, but we also post our changelog there. And so I check this once a week and make sure that I'm on top of all the new stuff we're shipping because even I can't keep up with it. So with that said, we have like 4 minutes left. I'm happy to answer questions about anything Claude Code related. We have it here. I can live demo some stuff if you're interested. Let's do a few.
Let's do him first, and then you. Okay.
Thanks. Real quick, this might be obvious, but multiple Claude.md files in a project, I presume that's possible and it just figures it out, or no?
So there's a few options. Of course, like in the same directory, you couldn't. But you could have one here and one in a subdirectory. And I think we changed this so that all the subdirectory ones aren't read in, because like Anthropic, we have a monorepo, and people would open it at the top and blow up their context with all the Claude MDs. So we encourage Claude, when it's searching around and it discovers Claude.md files in child directories that are relevant, to be sure to read them. But by default, it just reads the Claude.md file in the current working directory when you fire it up. And then also you can set one in like your home directory. There are things you can do though. We have this new thing, like in your Claude.md, you can start referencing other files. So you could, for instance, do something like this with an @ sign. If you have other Claude.md files that you just kind of know you always want to read in, to do something like that.
Hi, okay. I have not had luck getting Claude to respect my Claude MD. Like, there's one thing particular
Yes.
where I'll ask it to refactor something, and then it will leave inline comments explaining the what
Yes.
of it is, and it's like something that's extremely
Yes.
obvious. And so I'll tell it like, go and remove any inline comments that describe the what of what's happening, and then it will remove it, and then immediately do it again in like the same pass. So do you have any strategies for dealing with that?
So there's kind of two things that fix that. So that was actually kind of a model problem. There's nothing in the prompt. We have actually a lot in the prompt for 3.7 that said, whoa, do not leave comments. And despite that, the model just loves to leave comments. So it doesn't surprise me that your Claude.md didn't help much either. We already did a lot. I did a lot of work to try to tamp it down from what happens out of the box. So we mostly fixed that in Claude 4. Now there might be some new weird behavior quirks, but the other thing we made better in Claude 4 is it's just better at following instructions. And we've gotten a lot of feedback from early testers that all of a sudden, whoa, my Claude.md is being followed way more closely. And it might be a good chance to go look in your Claude.md and decide, do I still need this stuff? Maybe I can take some of it out. Maybe I need to add a few new things. So moving over to the new models might be a good time to take another look at what's in there and see what you need and what maybe can go.
For the record, I'm trying to think of something that you might not have thought of.
Yes.
When doing multi-agent execution and parallelization, can you make it so that for 4 agents, say, agents 2 and 3 use the context from agent 1, maybe agent 4 uses the context from agent 2 at a certain point?
Yeah.
Yeah, etc.
That's interesting. We're trying to, so kind of like I said at the beginning, we're trying to do the simple thing that works, which is just one agent that's great at coding and does everything. I think we want to figure that out. Probably what's going to happen is if you wanted to do that, you would ask all your agents to probably like write to a shared markdown file or something like that, so they can all kind of like check in and communicate. Sometimes like I'll be working with Claude.md or Claude, and I'll just say like, hey, I need you to write some stuff in like ticket.md for another developer, and then I'll fire up another Claude code and I'll be like, hey, read ticket.md, like another developer left this note for you, like this is what you're going to work on. So I'd think about trying to write that state to a file and then just kind of like count on the model's ability to just like read files and make sense of them. It's probably the best you can do today, and maybe we'll figure out clever ways to expose that in the product as something more native. Cool. All right. And with that said, I have some rare Claude Code stickers that I found in my backpack, so come find me. I'll be hanging out over there or something. Happy to share them. Thank you.
Can everyone hear me? Thumbs up, all good? All right. Everyone, I hope that you have had a fantastic day at Code with Claude London so far today. My name is Will. I'm on our engineering team at Anthropic. I sit on a team called Applied AI. What that means is I essentially split my time between internal engineering work and time spent building agents with customers. So folks, imagine that you built and shipped an agent to solve a problem. I'm sure that's something that a lot of the folks in this room have actually done. And imagine that this agent worked fantastic, right? But it worked so well that a few weeks after shipping, you were asked to add some additional capability to the agent. A few weeks after that, you received more business requirements and you added additional capability. This pattern continued and continued until before you know it, Your system prompt had grown to become several hundred lines long. You have dozens of tools and sub-agents that exist for your agent. And because of the complexity, you've started to see regressions in the areas that your agent was previously accelerating in. So if this is you, you're not alone. We see this type of scenario happen pretty commonly with customers, and actually with ourselves included in that. So within this workshop, we are going to simulate an agent that has essentially grown to a complexity where we start to see degradation in its performance. We're then going to walk through some of the decisions that we as engineers and architects make in order to improve the design of our agent to restore the performance that we expect with the additional capabilities. Specifically, we're going to make some decisions around tools and skills and sub-agents. As we modernize the stack of our agent, we want to make sure that we're using the right agentic primitives at the right time. So when do you use a tool, when do you use a skill, and when do you use a sub-agent? We're going to talk through all of that in this session. As I mentioned, folks, this session will be hands-on. So let's go ahead and get started. I first want to walk you through our problem statement in our agent. So for the purposes of this session, we're going to be focusing on an agent called Stock Pilot. This is an inventory management agent that was designed by and for a mid-size retailer. The agent that you see on the screen can do several things. It can flag low levels of stock. It can forecast demand. It can pick suppliers. It can file POs. And ultimately, it can write weekly reports for the employees of this retailer. Now, none of these capabilities are particularly complex on their own, but again, the issue is that we've essentially bolted capabilities onto our agent over time without modernizing our architecture. This complexity has started to cause some problems. Let's take a look at the actual architecture today of the agent. Folks, today the agent is facilitated by a single orchestrator. So you see the Stock Pilot orchestrator sitting at the top of the screen. The agent has a system prompt, as I mentioned, that's grown to be about 400 lines long. It has 12 different tools. 3 of those tools happen to be wrappers around sub-agents with completely isolated context windows. So if you have the repo pulled up, which we'll go into more detail in just a bit, there's an agent that's under a folder called Before, which essentially walks through this agent exactly. So again, orchestrator, long system prompt, a lot of tools. We have a lot of sub-agents. The result of this is that our evals have started to dip. So let's imagine how we got here for a moment. Again, like we built that agent up front to solve a really specific problem. We received business requirements to say add maybe some forecasting capability to our inventory management agent. So what we decided to do was essentially just spin up a forecaster as a sub-agent. Again, later on, we received more requirements to add report writing capability to our agent. So we decided to add another sub-agent for that report writing capability. Again, our eval started to dip over time because we added more and more complexity while just bolting this capability on. So let's take just a little bit of time and talk about evals specifically. For this agent, folks, we have 12 different eval tasks across 5 different types of graders. So my colleague gave a talk on evals shortly before this. Evals will have a component within this workshop, but it won't be the main focus. I'll give you a quick summary of the tactical evals that we're using for this agent. On the left side of the screen, you see some IDs. You see several evals that start with the letter R. This stands for regression. These are more realistic, single-turn tasks that we grade the model's capability on. So imagine I give the model a task. The model comprehends that task within the agent, calls some tools, and then provides a response back to me. We're essentially evaluating that response. We also have some more complex tasks that we're grading the model on. So you see those F IDs, the IDs that start with F on the left side of the screen. That stands for failure mode. In this case, we're evaluating the model over a more complicated multi-turn task that we're grading. Now, again, I won't go into evals too specifically. We have a number of different types of graders that are both deterministic and non-deterministic, right? When I talk about deterministic evals, we're grading things like turn count and like latency and like the number of tokens that are used as our agent is completing a particular task, and we're tracking those deterministic metrics over time. We're also using the idea of LLM as a judge to evaluate the non-deterministic characteristics of our agent. So personality and tone and style and output quality, we're using a non-deterministic grader as a part of our eval to evaluate our agent's non-deterministic characteristics. Now, we're going to run the evals for our agent in just a bit, but when you do, you'll find that the agent is struggling a bit. I'll talk about some of these evals in just a little bit more depth. So F1 on the screen, third from the bottom, this is essentially simulating a daily low stock sweep. So again, this is an inventory agent. We're simulating our ability to look through all of our inventory and pull the low levels of stock. This eval, you'll find, will actually fail because the agent is going to do the right thing, but it's going to take a very winding path to do so. So instead of taking the straightest line from point A to point B, the agent is going to take a very inefficient path. It's going to get to the right end, but it's going to fail the eval because it's not at the efficiency that we'd like. F2 on the screen is another eval that you'll see fail. This eval actually evaluates the ordering process under a particular promotion package. This is going to fail because we are using a sub-agent for this particular task. The sub-agent is actually getting the task right, but there's a communication breakdown between our sub-agent and our orchestrator. This is a really common point of failure that we see when customers have really complicated systems with a lot of sub-agents. It's important to get the communication between your sub-agents and your orchestrator just right. In the case of F2, like you see on the screen, this is an eval that's going to fail because we have a breakdown in that communication. The last one that I'll highlight that you'll see fails is R8 on the screen. R8 will essentially check the forecasting during a particular promotion month. This eval is also going to fail because we have two different policies that live in very different parts of our system prompt and actually end up contradicting each other. So I mentioned over time our system prompt has grown. We start to have some conflicts and the model gets confused, leading towards a failure for this particular eval. Now, in the repo, you'll see it in the README, when we run these evals, you'll see that they're going to pass up front at about 83%, which is okay, but if you work in the world of manufacturing, that is not okay. 17% failure is a really expensive failure percentage. Now, let's double click on R8 again, just so that we can understand a little bit about what's happening behind the scenes. Again, R8 is where we're essentially calculating the forecast during a particular month with a promotion. And so on my screen here on the right side, where you see kind of the simulated terminal window, within the first block under the commented text, we can see that the agent pulled the right forecasting baseline and also pulled the right promotion multiplier. So forecasting baseline, 12 units a day, promotion multiplier, 3.1x. This is all correct. But in the calculation part below that, we can see that there was actually some kind of hallucination that happened. Instead of using that 3.1x promo multiplier, the agent actually ended up using 1.35. So something happened along the way. A hint here is that the reason for this is that we have context problems. So this isn't a model problem. It's an issue with the information that we're surrounding the model with. Our system prompt has grown to be really long and is very confusing for the model and has some conflicts in it, which lead to the issue that shows up within this eval. So folks, our objective in this workshop will first be to run our suite of evals. We're going to triage the issues, and we're going to update the design of our agent accordingly. And then we're going to do something that we call internally hill climbing towards eval improvement, right? So we run our evals, we get a baseline. It's going to be about 83%. We're then going to optimize the architecture of our agent, and we're going to continue then running our evals so that we climb on them, hopefully seeing the success percentage improve over time. In this lab, we're also going to start with an agent that is self-created on our Messages API. Again, if you have the repo and you click on the before folder, I'll show you this in just a bit. This is an agent that is built from scratch on our Messages API. We're going to actually migrate that agent to Claude Managed Agents. Claude Managed Agents essentially allows us to offload the messiness that comes with maintaining an agentic harness and scaling agents safely and securely to thousands and tens of thousands of users, right? Like if I want to build my agent locally and run it locally, I can do that pretty quickly and pretty easily. But the moment that I need to take that agent, I need to host it remotely, and I need to allow hundreds and thousands of users to, at the same time, engage with that agent. There's an infrastructure problem, there's a scaling problem, there's memory, there's security, there's so much that I have to account for. So in order to offload that, so I can just worry about the architecture of my agent itself and make decisions around tools, skills, and sub-agents, I'm going to offload everything else to Claude Managed Agents. So again, to break that down just a bit, there's been a few talks on CMA so far today, but this is really where we're able to separate the agent from the session details, from the sandboxed environment where tool calls are actually happening. Again, this allows us to offload particular parts of the stack to then only worry about the design of our agent itself. All right. I mentioned that we're going to get hands-on in this workshop. We are going to go ahead and do that right now. Now, what you see on the screen here is the workshop URL as well. If you haven't had a chance to grab it, feel free to go ahead and do so. This is where we're keeping all of the different workshops throughout Code with Claude within London, so you can go back and revisit them if helpful. Within this workshop, we're going to be working on agent decomposition. So that's going to be the name of the folder that we're actually going to be working within. Great. Let me jump forward here. Perfect. So the first thing that we're going to do as a part of this workshop is we're first going to get a baseline. So when you open up that link, you'll first clone the repo. So we're going to clone the repo locally. We have a UV project that's set up, so we're going to run UV sync in order to make sure that we have all of our packages and our dependencies to be able to invoke the Anthropic SDK and then eventually deploy our agent to Claude Managed Agents. So we can run UV sync to do that. I mentioned previously that we're going to need an API key for this workshop as well. So using those credits that you got at the start of this session, you can go to your Claude console account and create an API key. If you copy the env example, you'll just have to manually copy your API key into the env file that's created for you. Now, all the 12 evals that I previously walked you through, we have all of those set up already. So in order to get a baseline and run those evals, you have to run uv run evals -- agent before. This is all in the README, but if you just run that command, you will be able to actually go about running your evals. Now, in terms of our building here, we're going to take a number of steps to actually go about running our evals, using Claude Code to triage the results of them, and then climbing accordingly on our agent. So we're first going to take a look at the system prompt that we have for our agent itself. So I mentioned earlier that our system prompt is currently sitting at about 400 lines long. We've been stacking information on our system prompt over and over again as we've continued to get more business requirements. So our system prompt is very long. We'll take a look at that. We are then going to take some time to evaluate the tools that we're using. Right now, as I mentioned, we have 12 different tools. 3 of them are actually kind of wrapped sub-agents. So we'll take a look to see what we can do to make that more efficient. And then lastly, if there are any sub-agents that we really need to make our agent effective, we're going to take a look at the best way to actually construct sub-agents with Claude managed agents. I'm going to jump back just for a moment. There's one thing that I forgot to mention for you as you get started. Within the repo folder, there's two different folders that you'll see. There's a before folder, and then there's a starter folder. Those contain two separate agents. So if you want to view the messages API version of the agent, again, this is just me building my own agent loop and my own agent harness around the Anthropic messages API to invoke Claude. You'll see that within the before folder. If you want to view what that agent looks like when deployed on Claude managed agents, you can look in the starter folder, which exists right below that. If you want to deploy your agent on Claude managed agents, you can run uv run deploy starter. So again, run your evals using the messages API version, -- agent before. You can then deploy your agent on Claude managed agents. We already have it built for you, and it's really easy to use Claude Code to kind of compare the two and understand exactly what's going on and what some of the differences are with Claude managed agents. Okay, so I'm going to jump over here, and we're just going to open up Claude Code, and we are going to build together. I'm going to zoom in very far so that you can see everything and so that I can see everything. And we'll just talk through exactly what happens when I run some of these evals. And we'll talk through the process that we usually go through to do what I just called hill climbing on the evals themselves. Okay, so if you're looking at Claude Code here, again, I just used Claude Code to actually run my evals because I want Claude's help in triaging what's going on. So this is me. I'm using Claude Code. I have Opus 4.7 running, as you can see on the screen. My effort level is set to extra high. I usually set effort as extra high with Opus 4.7, and I forget about it. That's the effort level that I usually stay on. We find that it gets great performance with extra high effort altogether. Now, you can see on the screen, the first thing that I did was I ran my evals. So I used the bash capability in Claude Code, and I ran uv run evals -- agent before. Claude actually went ahead and ran my evals. So I'm going to scroll down, and we're going to look at what Claude found while actually running those. So you can see the response that we got, the results that we got from this eval run was actually lower than what I told you before. So we ran them and we got 62%, which is worse than the 83% that we started with. So we passed 7 out of 12 of them. And it looks like Claude has provided us with a diagnosis for the different evals that we actually failed. Let's scroll down just a bit more. And we are going to use Claude to understand a little bit more about why this actually happened. So you can see here, I am using Claude to provide me some of the themes around why we actually failed some of these evals. Again, this is a great technique. If you have evals for your agent, again, as Giri showed before this session, you can use Claude to actually go about triaging these. So it looks like there's a few different themes that Claude is figuring out based on this agent. So the first thing, Claude is seeing that our model is taking on a lot of work that it should have tools in order to do. So our model is doing a lot of reasoning across information that it just doesn't have the tools to be able to complete. It looks like there is some issues that we have with the enforcement of output structure. So our model and our subagents are producing information in a particular output structure that doesn't align exactly with what we're looking for with to pull the best performance from our agent. If I continue to scroll down here, you can see there was some policy issues, etc. As I mentioned before, we have a system prompt that's really long right now. And so Claude is seeing some confusions based on the information that's found within the system prompt. So again, you can see Claude has found some root causes. Now, we're going to do a few different things here. Again, we're going to go one by one and address some of the areas that we're seeing issues on within our agent. So I'm going to scroll down here, and we are going to use Claude Code to triage some things within our agent. Okay, so the first thing that I'm going to ask Claude to do, we're going to talk through this. Claude is making some changes, which is great. System prompts tend to get very, very long when we accumulate agents over time. So the first prompt that I ran, if you're following along, feel free to go ahead and do this. I encouraged Claude to look at my agent.py file, which is where our main CMA agent loop is located. Again, that's agent.py. And I essentially said, hey, Claude, do you have any thoughts on the system prompt? Maybe I can use skills instead of a long-running system prompt for progressive disclosure. So the first thing that we'll talk about is skills. There's been a few other sessions on skills. The short definition that I like to use is that skills are packaged and composable information that Claude has the ability to pull into context whenever Claude realizes that it needs that information to complete a particular task. Right? Skills are really useful with Claude Code. Like if you need to provide Claude information on your testing process, or if you want to package up your brand and your UI components and bundle them into a skill that Claude can pull into context whenever needed, skills are fantastic. Skills are also useful within the agents that you're building for your customers. So if you're building a product and you are going to give that product to customers, you're building an agent, skills are great within that. In the case of the agent that we have on the screen here, again, we have a lot of different policies and a lot of procedures that go into our inventory management system. As I accumulated requirements over time, instead of building skills, I decided to take all of that information and keep appending it to my system prompt. So my system prompt got longer and longer and longer over time. This is not something that we recommend you do based on the introduction of skills, right? Leave the system prompt only for the information that Claude needs in its mind, regardless of the task that you give it. Skills are fantastic for packaging information that Claude is going to need some of the time, not all of the time, right? So if I ask Claude to go build a forecast, Claude is going to go ahead and do that. Let's see, I lost my computer just for a second. There we go. If I ask Claude to go ahead and build a forecast, right, Claude is not going to need forecasting information unless I specifically ask it to go ahead and build that forecast, right? So in the case of that particular task, I want Claude to pull forecasting information into its context window. Skills are also fantastic for making sure that you are being efficient with context, because if you stuff all of this information into the system prompt, you're polluting that context window with information that Claude does not need in order to complete a particular task. So again, the first thing that I did, I'll zoom in just a bit more so that you can see this, and I'll scroll up just a bit. I said, hey, Claude, can you help me take a look through my system prompt? Can I use skills instead? My system prompt is too long and I need some help. And so Claude did an analysis of this and realized that I have some pre-built skills that I can use to supplement information in my system prompt. So the first correction or fix that we're going to make to modernize our architecture here is we are actually going to remove much of the system prompt, and we're going to put that information into skills. And so you can see here the first thing that we're doing with Claude is we are activating a number of different skills that previously were not there before, and we're actually swapping our system prompt to be a short prompt instead of a long one. So if you're curious, if you feel like you have a long system prompt within the agents that you're building, feel free to take a look at this to see the differences between what was like a 400-line system prompt compared to about a 50-line system prompt. We've supplemented that, and we've switched a lot of that information to skills. Great. I am now going to continue working with Claude. So you can see we made those changes here, which is fantastic. There's some evals that I can go rerun. I'm going to ask Claude to do one more thing, and then we're gonna rerun some of our evals to see where we've improved. So I mentioned before that we have 12 different tools. You saw those on the screen in the second slide that I shared. As a part of this inventory management agent, we have tools that we've created for everything. So whenever Claude needs to retrieve data, we have a tool. Whenever Claude needs to analyze data, we have a tool for that. We have tools for everything. So I'm going to ask Claude to take a look at the tools that my agent has and help me think through how I can optimize here. So right now, Claude is running an analysis across the different tools that I have for my agent, and we're going to get to see what some of the results for. Now, while this is working, I'll give you a tip when it comes to building agents that we carry with us at Anthropic for our agents internally and the agents built with customers. Whenever we build agents, we lean into the same primitives that we as humans have access to. So imagine yourself when you show up to work, right? You have a computer that's sitting in front of you. You have the ability to navigate files on a file system. You can type in the browser and you can search the web. If you're an engineer, you have the ability to write and execute code. When you think about Claude Code as an agent, we've effectively given Claude access to all of the same primitives that you and I have access to when we show up to work every single day. Like Claude Code is a great coding agent because Claude is really good at code. But essentially what we've done with Claude Code is we've just given Claude access to a computer, right? And this is really powerful because this allows us to drop in better versions of Claude as we continue to release new models. And Claude just uses those primitives better than it did before. Right? Like imagine yourself after this conference compared to yourself when you walked in. You're going to have the same tools at your fingertips, but theoretically, your brain's going to be a little bit bigger. You're going to be smarter based on what you learned here, and you're going to be more effective while using the same tools. Claude works the same exact way, right? And so whenever we build agents, we lean into human-like primitives first. These primitives are things like code execution, and the navigation of a file system, the keeping of a to-do list, the ability to search the web. These are foundational tools that we always start with when we build agents, and we remove them as needed. An example that I like to give is with like document analysis. If you're building an agent that requires document analysis, maybe you have a lot of CSVs or Excel sheets that your agent is going to be looking over. Code execution, so the ability to write and run code, is one of the best ways of doing data analysis and working across lots of documents, right? Like if you need Claude to look across the CSV, giving Claude a bash tool so that Claude can write a quick Python script and reason across the results after running that Python script is much more effective than just uploading the entire CSV into Claude's context window, right? So again, we lean into these computer-like primitives first when building an agent. So if I scroll down here, that's exactly what we did here. You can see we took a lot of steps and we actually removed most of the tools that exist within our agent, and we replaced them with some of the primitives that I talked through previously. This is an inventory management agent that leans really well to this. I have the ability to consolidate and remove a lot of the tools that I'm using to reason across Excels and reason across forecasting data and just give Claude access to the same tools that Claude Code has in order to do that. What's cool about this is that when you build using Claude managed agents, these tools are actually included by default. So if you want to give Claude access to those same tools that Claude Code has and use them to drive powerful capability within your agent, you don't have to worry about writing a tool that gives Claude the ability to write and run code. Or you don't have to write a tool that gives Claude the ability to use the file system. You can just rely on those built-in tools that we have built ourselves for Claude Code that we just make available through Claude managed agents. I'm going to ask Claude to rerun an eval. The evals to see if we are getting better. Now, with your agent, there's always going to be the need to add some custom tools as well. Like you're only going to get so far by giving your agent the same tools that we give Claude Code. So we always start with those primitives like code execution and web search and to-do lists, etc. We always start there. And then we either remove those tools as we don't need them, right? There might be some agents where we just don't need web search, so we'll go ahead and remove that tool. And then we'll add custom tools whenever we need them, right? So again, when you think about tools, I encourage you to start with those Claude Code primitives, those human-like primitives, and then add custom tools only as you need them. In the case of this specific inventory agent, we were able to remove most of the tools and replace them with Claude Code. So you can see right now, Claude is redeploying my agent to Claude Managed Agents. So again, I have my agent locally. I am redeploying it based on some of the changes that we've made, and now I can rerun some of my evals to see the result. So you can see in that last command, I'm rerunning the F1 eval, and we're gonna see what happens as a result. Now, we always get a lot of questions when it comes to MCP. So in the case of CMA here, you have a couple different options when it comes to tools. You can first lean on those Claude Code primitives, things like web search and code execution and file system. Again, that's what we start with. You can then create just custom tools, so standalone tools that only your agent has the ability to use. Then you can connect your agent to MCP. We see a lot of folks run towards MCP first, and a lot of our customers end up in this ecosystem where there's a lot of kind of chaotic MCP servers that exist. A lot of times they have overlap, which can create some problems. So when we build agents, again, we start with those Claude Code tools. We then create local tools only for our agent. We don't run to MCP. And then only in the case where we have a common collection of tools that multiple clients will benefit from accessing, do we go about the process of collecting those and publishing them as an MCP server. So only when we have multiple agents, maybe multiple Claude Code clients that need to access the same set of standardized and governed tools, we run towards MCP. Something else that's becoming increasingly common throughout the industry is leaning on Claude's ability to effectively use code execution as a means of executing tools. So we see a lot of capabilities coming out around just giving Claude access to use CLIs and invoke APIs using code and actually run tools using code instead of MCP. One of the drawbacks of MCP is that it does cause some context issues just in terms of polluting context and taking up a lot of space. So there may be some cases where you can just rely on code execution, either through CLIs or just by giving Claude the ability to invoke APIs using code as a means of creating more flexibility for your agent where you do not have to use MCP. So just something to keep in mind as you're building. Great, okay, so Claude just got done. Looks like we have the before and after from some of the changes that we've made, and I think that this is pretty compelling, right? The first thing that jumps off the screen to me is the token usage. So before I was using over 200,000 tokens for a particular task. After leaning in on some of those file system primitives, you can see that that went down dramatically. This is a direct result of giving my agent code execution. So again, imagine instead of giving my agent a full CSV that needs to be read into context, I just give my agent the ability to write and run Python as a means of kind of navigating across all of that information. The agent uses a lot less tokens when it can write code and then run code and then read the results, instead of having to consume all of that data in Claude's mind and then use all of that kind of collective brain power to then make decisions based on the results. A few other things, we can see that our costs went down as well because we're just not using as many tokens, which makes sense. Our execution time went down as well. So this was a pretty good case where I think we got better overall, but this is not something that will happen all the time, right? We might see some cases where we regress, but this was the case where using some of those primitives as opposed to some of our more stagnant tools was clearly the right decision. Great. Okay, we're going to jump back and we're going to talk about subagents for just a bit. I'm going to copy another prompt to Claude, and we are going to investigate subagents. Now, I mentioned before that we had 12 different tools. 3 of them were effectively wrapping subagents. So if I'm Claude, I have the ability to call on a tool. That tool is a wrapper for a subagent. I can then go and invoke that subagent. See, Claude's doing a lot here. I'll scroll up just a bit, and then we'll talk through it. The 2 main use cases or the 2 main instances where we see subagents initially as being really effective is first when you want to throw a lot of Claude at a problem, right? So let's say that you're trying to do deep research or like web search. Let's say that you're trying to do, in the case of Claude Code, code-based exploration. That's a great case where like having many different minds running at the same problem makes sense. So subagents are a great way to parallelize and throw a lot of Claude at a problem to get it done faster and more effectively. The second case where it's really common to use subagents is when you need a fresh mind to look at a problem. So I'll use the Claude Code example first. I'll use my example as a developer. If I am writing code, I do not want to be the same person that is writing and also reviewing my code. I'm going to have somebody else review my code. So in the case of Claude Code, it makes a lot of sense to have one instance of Claude doing the writing of the code, and then another instance of Claude coming over the top and reviewing that. That does not have context about the initial instance of Claude. This is a great case for a subagent. Using just a code review subagent and layering it over the top is a great way to do this. We also have a subagent within our agent here, our inventory management agent, that we've actually kept as the result of some of the changes that we've made, and that's for forecasting specifically. So again, I have a forecasting capability that's within my inventory management agent. I do want to keep my forecasting separate from my main instance of Claude. I don't want anything in my initial context window to distort the forecasting process. I do have a skill that kind of walks through the step-by-step sequence and the guidelines that I prefer Claude use when writing and building forecasts. But again, I don't want the same Claude that my customer is talking with to also be the Claude that writes the forecast, right? So I want to divide that. So I'm leaning on that second example of when to use a subagent as the place where we'd like to go about doing this. So in this case, we've removed our other subagents and we've just replaced them with primitive tools, but we are going to leave the forecasting subagent. Now, we're not going to expose our subagent as a tool. Using Claude Managed Agents, there's a native capability for subagents that allows the logging and the observability of your subagents to be really effective. One of the problems with subagents is that when you have multiple instances of Claude running, first off, it's difficult to make sure that the communication between your orchestrators and your subagents is accurate and is seamless, right? There's a lot that can get lost in translation. Just like when I'm talking to one of my colleagues, I might be thinking something, they might be interpreting it completely differently. The same thing happens with orchestrators and subagents. The other thing that can happen is logging is really difficult in some cases, right? Because then you have to worry about collecting the transcripts from multiple different agents. So within Claude Managed Agents, we've added this native subagent capability. I saw it on here. Let me scroll up just a bit. I think Claude found it. Yes. So there's this callable agents capability that exists within Claude Managed Agents, which is essentially just like managed subagents, so that within your session information, you have observability and metrics about what exactly your subagents are doing that is as accurate as your initial orchestrator, right? This is, again, meant to solve one of the common problems of just having a lot of information that is hard to track with subagents. We just did some building. Again, I'm going to skip through these because we spent some time talking about them. We just talked about subagents. Again, there's a few different cases where you can use them. We just talked about callable agents. You can also just define your subagent as a tool, which is what we did previously, but we actually moved away from that and we decided to use the CMA native capability. There are a lot of cases where you can just now scrap the subagent entirely and just give more flexibility and capability to your main agent. So what we have a lot of customers doing is actually just consuming capability into their main, in this case, orchestrator, because frontier models have gotten intelligent enough to manage across more information where you just don't need as many subagents. So again, when you're thinking subagent, I had a lot of Claude, or I have a big problem that I want to throw a lot of Claude at, or I want a separate Claude to kind of look at the work of either me or of a different instance of Claude. Two great times to use subagents. Okay, so let's look at the architecture that we ended with. Again, refreshing us, we started with an orchestrator, system prompt of about 400 lines long. We had 12 tools, 3 of them were subagents. What did we end with after this exercise? We still have an orchestrator, but we deployed that on Claude managed agents because I didn't want to have to worry about infrastructure, scaling, security, etc. I just wanted to worry about my agent. Right? Like in Will's simple terms, like that is when I reach for Claude managed agents because I just want to worry about building the best thing possible and not all the messiness that comes with it. We simplified our tools. We now have, right now 3 different tools. So we actually simplified everything to just use bash, read and write. Now, when our agent starts executing, we sync some data into the Claude managed agents environment so that it can reason across that data. We actually simplified our system prompt to 15 lines long, and we replaced all of our business logic with skills. So again, I was just stuffing requirement after requirement into my system prompt. I decided to take that, package it up as skills so that Claude could pull that information into its brain only when Claude realized that it needed it in order to solve a problem. As a result of this, we showed how we can then start hill climbing on evals to see improvements over time. So at the end of this, my eval score is about 92%. I've simplified my design. I'm leaning into some of the primitives that make Claude great. And I'm seeing the positive results after doing so. Again, some of the eval results, you see that here after running this. We're getting faster. We're using fewer tokens because we're leaning into code execution. Our turn count is remaining sort of the same, but again, because the token usage and the cost is going down, I'm actually okay with Claude taking more turns. There are some cases where we'll see the latency not drop maybe as much as you would expect, but for some of these more sophisticated high intelligence agents where like forecasting is at play, I'm willing to take a little bit higher latency at the expense of seeing my performance improve and my costs go down. All right, let's wrap with some takeaways here in our last minute. When we build agents, we start with a single agent loop that is equipped with very simple primitives that give Claude some of these human-like capabilities, like the ability to use the file system, like the one that you have on your computer, web search, code execution, sometimes a to-do list. Again, we start there and then we build accordingly. The next thing that we did is we used progressive disclosure through skills. Instead of stuffing our system prompt with a lot of information, we made information accessible to Claude whenever Claude realized that it needed that information in order to solve a problem. This is great because we can run more efficiently, and we're not polluting our context window, and we're giving Claude more flexibility to make decisions. The last thing that I want you to walk away with, right, evals in general, this idea of hill climbing is a concept that we lean on really heavily at Anthropic, right? You have evals, you establish a baseline, you then tweak your architecture and you rerun evals and you get better over time. Now, as a result, it's important to make sure that your evals are updated as your product capability expands. Always make sure that your evals are encompassing the things that you care about and that you're measuring within your agent so that you can actually make sure that your agent is accomplishing the thing that you set out to accomplish. With that, folks, we're going to go ahead and wrap. I really appreciate your time today. I'll be in the back after the session, just outside of this room, in case you have any questions at all. Thank you.
Welcome all. Thank you for joining the workshop. We have a pretty full house here today. I'm very pleased to see that. Quick show of hands. Who here loves Claude Code? Okay, yeah. You're in the right place. Yeah. Lovely to meet you all. My name is Arna. I'm a member of the Applied AI team. I'm an architect there. I'm here today to tell you how we Claude Code at Anthropic. Do a workshop, and you can code along. You'll get some credits. I think there'll be a QR code in just a moment, so make sure to grab that. There'll be people floating around that might support you. So if you have technical difficulties, we can help you out. Anybody here in this room who hasn't used Claude Code before? Okay, great, good, because this is, there's more to do. There's more to find out. I'm happy you're here. Let's get started. So, let me get my clicker. Yes, excellent, yes. Please grab the QR code, set yourselves up. There'll be a repo here as well that you can clone. There are 3 phases in it we're gonna work through. There's an interesting verification setup that you can work through alongside me, and it's quite detailed, so you probably will want to investigate it a bit later yourselves. What we're covering today is based on this version of the talk that Tarek gave in San Francisco just about a week and a half ago. Who here follows Tarek on Twitter? Fantastic, great, yeah. So he published that as a blog post called The Unreasonable Effectiveness of HTML Files. And he's basically pitching that moving on from Markdown files, we're going to be using HTML instead. And we're showing some of that today. Like I said, there's a repo to go along. Enjoy that along the way and later on in the week as well. Where are we now? Where's this all going? I think everybody probably notices that agents are becoming more and more capable. Why is that happening? That's happening because the models are becoming more and more capable. And so if the models become more capable, it means agents can run for longer and you can give them more and more complex tasks. But that also means that we have to change our way of working. We have to change our habits. That's part of what today is about. How can you change the way that you're working with Claude Code to get more out of it? If you're going to let your agent run for a longer period of time, then you can burn through a lot of tokens if it does the wrong thing. And you want to avoid that ideally at the beginning. And so that's where the idea came from, to push more and front load more of the verification that the human would do in the spec into an HTML file because it's a more rich and more human ergonomic way of engaging with the content that your agent is going to be building for you. And we'll see how that works. There are a bunch of things around agents that are worth reading. We have a lot of engineering blogs on our webpage. We also have the standard blogs. You should check all of those out. There'll be a lot of information there. There's a lot of interesting information about harnesses, about long-running agents. All of these things are important. Today, we'll focus on 3 levels. And there'll be something a bit more basic, something a bit more next level, and then something that's quite interesting, and that'll be a bit more in-depth. The first thing is, the more capable the models get, the more you should try to resist constraining them. Who here, by the way, has heard of The Bitter Lesson by Richard Sutton? Great, fantastic, this is great. So I'll for those who haven't raised their hands, Richard Sutton is basically the father of reinforcement learning. If you're reading a book about reinforcement learning, it's probably authored by him. And his idea was basically that you could spend all your time trying to, with your human capabilities, hard code up front and constrain the system, but in the end, pouring more data and more compute at it ends up getting more capability than anything that you could have come up with. And there's a similar analogy here, right? The models are becoming more and more capable, and so you should accept that the model is probably better at extracting requirements from you than you are at defining your requirements. The requirements are latent within you, just like when you talk to your users. Your users, they have an idea of, they know it when they see it, but they're often not very good at articulating what they need. And likewise, you probably know what you want when you see it, but Claude is likely better at extracting what you want and what you need from you than you are in specifying it to Claude. That's another direction to take this in. So we'll talk about that, removing ambiguity, letting Claude prompt you and interview you in prompting. Then how to then understand and plan. We used to do this all with Markdown files. We still do it with Markdown files. A colleague of mine once said, the Markdown file is the lingua franca of the AI native software development lifecycle. I thought it was pretty poetic. But it seems like that format is a bit constrained. It's getting too long. There's a lot of lines of Markdown file to read. We can condense more information into HTML files, and that's what we're going to do today. And then how to verify. Not test, actually, but just to verify in this context. How to make verification native to the thing itself so that the agent can drive it alongside a human, or eventually not, headlessly as well. That's where this is all going as well, right? The agents are going to be doing more and more of this natively. And how can you set the artifacts that you produce up to natively be testable and verifiable in the way that you need? So we'll do an example. By the way, has everybody had a chance to grab that QR code and set themselves up? Very good. There'll be a link to the repo eventually as well. I think that comes in a bit. Let's say we want to do a build splitting app. Very simple. You go out with friends, you want to find out who owes what. Yeah. Let's let Claude interview us around doing this. So in this case, I'm actually going to, before I do that, give you an example of how you would do this and how you could do this better. Yeah? What's good prompting, what's bad prompting? Bad prompting is when you say, just make it better. And a lot of people that I watch using Claude Code just type, make it better. Make no mistakes. Yeah. That's not good prompting. You want to encourage Claude to extract from you specific details. So give the domains. Don't over-specify the outcome, but specify the areas that you are interested in. Right? That's what makes this good prompt on the side different and better. Focusing on the audience, for example, or suggesting an open-ended way to answer the question, as opposed to predefining it up front. And then that will prompt Claude to iteratively interview. All right, so I've got a Claude open here, 2 different Claudes. Who here has used fast mode? Okay, not that many people use fast mode. That's why I set it up here. And who here uses auto mode? Oh, I'm very happy that you all use auto mode. You need to be using auto mode. If you're not using auto mode, you need to be using auto mode. It makes it so much easier. Use auto mode. Good. Who here is setting their effort parameter? Good, good. Our recommendation is X high, but you can also set max effort. I mean, in my case, I think I kept it at X high for this. So just to touch on how those look, right? Like we've got /effort, which is the effort parameter, /fast, which is the fast mode, which is I've turned it on. And then we have the auto mode, which we cycle into like this, shift tab. Yeah, auto mode is the best. So I'll copy paste you all, when you have the repo, will see one of these prompts is in there. So I'll just copy paste the prompt in here on the build splitting app. So, okay, Claude's going to ask me, you tab through these, right? Like you'll tab through these like this. And in my case, I want to just for friends. And I want it, is there a secondary audience? No, no secondary audience. And we'll leave that as that. The key thing here in the prompt is that you want to prompt Claude to use the ask user question tool that you saw me use in the prompt earlier before. Let me submit those answers. And then it'll write that spec, right? So you saw me in my prompt explicitly referring to the ask user question tool. That's what triggers this workflow. And depending on how well you specify that prompt, you'll get better outcomes. So it'll generate a spec. We could then turn that into a bunch of different ways of building the app. It's going to take a while, so we'll go back to my slides. Could I go back to the slides, please? Great. So let's say we have a plan generates a plan. We've answered some questions. It's getting better at extracting turn by turn from me what I actually want without me having to upfront verbalize everything myself. Then I want to be able to check, is it what I want? Well, an HTML file is more dense, much more information dense, much more ergonomic for you to understand what the thing is going to look like. You can even use a screenshot with it. You could use the Playwright MCP later on for that as well, right? You can interact with it much more richly than you could with a very long Markdown file. And especially if the Markdown files get, if they get more than about 200 lines long, it's unlikely you're going to read it, and certainly unlikely that your colleagues are going to read them. Before we started here, I had Claude with Opus 4.7 generate a few examples for me of what this could look like with my bill splitting app. And we'll look at those now. So we have them here. The prompt I used is in the repo that you'll have access to. I asked Claude, give me a few different directions, 4 different design directions, explore them, generate them as HTML, and let me explore them across each other. And they came up with these different ones. So one sort of brutalist, one Tokyo, fintech. We'll click them all one by one. So this is what this one would look like. And then this one might look like this. Completely different aesthetic, right? And I click around. And this is much better for me to give feedback to Claude on than it would be to just try to infer from a Markdown file what the thing is going to look like. I could go in and, like I said, take screenshots, feed them back into Claude. Who here regularly takes screenshots to give information to Claude? Very good. You should be doing that. That's very good. Especially when you're doing front end, it's really hard to articulate, like, the thing is slightly off, or there's a misalignment here, and it's like, you'll find that you run into the limits of what you can express, and it's actually easier for, especially Opus 4.7, which has a much better vision model than before, to extract from you what the problem is, and proactively. Great. So, a few examples. Tarek has a lot more in his repo, which you'll find in the repo as well, online. So far, we've covered letting Claude extract information from you interactively as an interviewer, because the longer you let an agent run, the more important it is that the spec is comprehensive, the less likely it is that you will be able to upfront define everything, and it's better for you to iterate with Claude in that manner. Then, what's a better and more efficient and ergonomic form factor? It would be the HTML file. And now, the more important part from all of this is how to verify what Claude has done and how to make it agent native. And that's what we're going to cover with the repo. I think we have, I think there'll be one slide where you'll get to see the actual slides to engage with, the actual URL to engage with. So what you want to do is make it part of the artifact. And that's what we're going to cover today. In fact, there's part of what we're doing today is we're going to use Storybook, fixtures, a testing library, sort of data emissions and attributes, and Playwright MCP for a React app, with components that you will have seen before, but remixed in a way to make it easy for Claude as an agent to extract the data contracts in the DOM and then run verification and then even record the verification, which is how the Claude code team that Tarek is on runs this, and that's what the demo that he built refers to, right? Like, it'll be a generation of verification steps that get run through, that get a recording, and that's then put on S3 or shared somewhere else with colleagues, and that's how you turn these verification steps into something that is generated by the agents, and then that you have fewer and fewer touch points with. That's something that you can replicate, especially from that repo. The way to do that is to sort of sensibly modularize, but that becomes really clear when we look at the actual thing. So I encourage you to go to that link. There'll be a repo. This is the repo under CWC Workshops, Claude with Code Workshops. And there's the one for today's session, which is How We Claude Code. What's covered in there is phase one, which we just covered, right? The simple prompt to say, hey, I'm writing a bill splitting app, interrogate me on the requirements so that I don't have to miss any in my upfront description to Claude. The second one is generating 4 different HTML design directions that we could explore for me to then feedback on or for me to decide. And then thirdly, we have a verification framework here. And it's in a different context. It's not to do with the bill splitting app. It's regarding a to-do app, a small to-do app written in React. And we're going to show how we built verification entirely into that along the way. That's described in detail in the README for phase 3, and then also in the verification detail as well, which is here. So if you want the deep dive on how this is set up, you can read this, and it's all provided in the repo. It's pretty cool. What is it focused on? We've written a small Todoist app here. I can add an item, test. It's hard to see. There we go. Very good. And then I could tick it off and drop it as well. And I could clear the finished items. And so many things are happening here in terms of the state, and we'd like to verify that it's all working alongside the tests that are already defined. But these verification steps, we'd like them to be driven by an agent. There are 3 ways that we're going to do this. So we're going to do this in a human-readable way. But then that same way of doing it in a human-readable dashboard, we're going to verify in an agent-first way and let Claude do that separately. And then there's a separate way in the repo as well. You can just run verify, and then it'll just run the test matrix there. You'll get a slightly different result if you do it from the repo versus here, but the principle is the same. So human-readable, agent-driven if you're doing it from Claude Code or somewhere else, and then also just generally headless like you might do it in CI. We'll have a look at it in a bit more depth. We'll go here into the app, and we'll actually look at, there we go. We'll look at elements. We have here the actual emitting, so the emitting different data aspects, the data verify unit, the total done and active. The component itself here is publishing its state to the DOM. And so if I change my state here, I might add test again. See that updates, and then I drop it, it updates again. So this is what the agent can read later, as opposed to having to scrape the DOM. We can just, if you publish the state here separately from the React internals, you'd be able to run the verification independently of whatever the state of the app is. And that's how this is set up to work. And then you can run this further down the line as well. Each one of them gets this, right? If you look at, if I pull up the, that's a bit hard to read. Let's do that here. Every component gets one of these, right? There'll be schemas, there'll be fixtures, the known states, and then the invariants. There are particular ones here that always have to hold. You'll test them with probes, and we'll do one example, which we've hard-coded. We've hard-coded an example that will fail the verification, and we'll let the human-verified dashboard catch it, but then we'll also let the agentic way of doing it cache it as well, and we can let Claude Code find it and diagnose it for us. So that same approach also works here. So I've got the dashboard defined here, and what we see here is, there we go. Like I said, we've got the different schemas, the invariants that we've defined, and we can run these, right? Individually, we can see how they would execute here. Got an example here. Or also, I could run all of them. In fact, I'm going to do that now. I run them all. One of them triggers artificially because we planted it before. We're going to scroll down and find out what that is. And it's here. We will actually look at how we can replicate this for an agent as well. And we would do that like this. Go here. Inspect. we could run basically the manifest of all the different verification steps that are defined here as state in the DOM. We can get them in the same way that we have them here. We expand that. It's getting a little bit small. As an example like that. And then like that as well. Great. If we do that, then we can also actually run them just specifically here. I'll do it manually first. Let me replay them all. Close that. In this case, we're running this, not to perform the verification, but to provide the evidence of the verification. We can later on record this. We can record these as clips, which would just be videos that we capture. And then we would store them, share them with colleagues, put them on S3 or whatever it might be. Let me pause that here. There we go. So here's our summary. We have one that's deliberately failed. I'll explain that in a second. But in each case, you can also see the details of how this was done. The key thing here is that we want to, it's important to include the probes to push off the happy path. And then a lot of this will be generated by Claude for Claude, right? So there's a way of scaling this further. In the end, we'll go to the one that didn't work. So the one where we hard-coded that the sums don't match. In this case, the state doesn't match. 3 plus 4 does not equal 10 in this case. And we'll get the same result if we run verify all from the Claude here as well. And we'll let Claude do that in a moment as well. There we go. Then it's a little bit hard to see that there's pass, and fail. So there we go. Okay, good. We can change this, right? The point here is that I'm trying to show that the idea is to let something agent native be read as the DOM contract here. That's what we established earlier, that the state is managed here, or well, not managed, but at least viewable to an agent, that it can then run the verification end to end itself. And we can let Claude do that afterwards as well. In this case, we can also make a change that will break more. Let me see if I can break the chain. I'll break the contract, but not the app. And I'll do that here. So I could change, for example, here. Under to do app, total stats, I'll delete that. I'll undo that afterwards as well. And if we now rerun, then all of these ones at the bottom here will fail. And we'll get the same when we run this again from here as well. Oops. There we go. All of these are failing, not because we broke the app, but because we broke the contract. That Claude can then natively verify. Excellent, great. I want Claude to tell me what's going on with these ones. At least, well, not the ones that I broke, but I'll undo the ones that I broke. But I'd like it to tell me what's going on with this one. And so let me correct the change that I made before. Control Z, autosave, rerun, and there we go. So we've done it manually, and we've shown how we can match what the agent would see versus what we would do. But we can let Claude run this headlessly itself as well. So I'll do that, and I'll pull that open. Just let it run. This one's broken, deliberately, and the rest works. Great. So we have Claude running here. I mentioned fast mode before. I mentioned auto mode, which is great. I mentioned /goal. In this case, what we're going to do is let Opus 4.7 help us find out why that particular verification failed. I've already connected the Playwright MCP for this. I'm going to use that, and it's going to run. Schema got rejected. 4 + 3 does not equal 10. Yes. If you were to run bun verify, then you would actually pass the tests in this case because we've deliberately put the verification in wrong just to demonstrate that then the test matrix itself will actually pass. But the idea here is to separate out what you could do as a human versus then what you could do via an agent directly from the browser using basically the commands that you saw, and then also what you could run headlessly directly from the CLI. If you wanted to do it like this as well, then you could record the outcome that we talked about. Yes. So here, in this particular setup, you've actually got the ability to show how you would record these. The same delayed running that we've shown, you could run and record as evidence, basically to show that it would work, and then you could store that. And they could run like that. This is very common right now. The Claude Code team records basically all the code changes that they do like this, all the front-end changes at least, especially at the pace of the shipping that we have at the moment. Are people able to pull up the repo and get the verification setup working? Yeah, very good, very good. Yes, you can store them. I mean, like you can just put them in S3 or whatever, or share them with colleagues. Or in our case, we have a version. We have an internal. This is more automated than what I'm showing here. In our case, we do record them. Not certain for how long or in what context, but it's part of a regular cadence. And then you get the. In fact, you get the. I should have triggered that. Did I not see that? There we go. So you have each clip. You could download all of them or download them individually, and then that's basically the bundle that proves the verification worked. So I guess to bring it around to what we've covered so far and where it's going. 3 different surfaces: the human surface, right? And then the agent first from the browser. Mapping on the same way. And then you could also run it in CI with just run bun verify. The objective here at the end is to figure out how do you embed the verification into the artifact itself. There's more detail. I encourage you to check out the repo itself and actually run a few examples yourself and run a few tests. Right? You can change the code, see what breaks, rerun it yourselves. It's quite detailed, and it's what Tarek and team use in the Claude Code team for their work already. This came pretty quickly, just a week and a half ago into this demo. So I encourage you to check this out. What's new really is the remixing and the new arrangement of primitives that you're already familiar with, that you're already using, just to make it available to be agent first. That concludes really.
Everyone, thank you for being here today. I'm pretty much excited to have this session with you. I know we are almost at the end of the event, so thank you for bearing with us. So just to start, let me introduce myself. I'm Ivan Nardini. I'm a developer advocate at Google Cloud, working on building content in partnership with Anthropic. And in order to start this presentation today, I just want to ask a very simple question. So how many of you in the last week used any AI tool to code or build application? OK, the majority. How many of you use the same AI tool to build and deploy application on Google Cloud? Yeah, just a few of them. So the goal here today is just try to make it better. So in this demo, what I'm going to show you is how you can use Claude on Google Cloud to build and deploy application end-to-end. And in order to do that, I'm going to wear 5 different hats. And we will start from, imagine the use case, right? Imagine the scenario. You are an enterprise context. In an enterprise context, you probably have a team like the one that we are visualizing here that it's engaged to build a new feature or a new product. So starting from the left, you probably have a PM. Some of you in this room are PMs. And the PM might have an idea of how to improve a particular product or how to implement a feature. And starting from this idea, he shared this idea with a UI UX design, which allows him to design the idea, to visualize the idea. And after the idea starts getting a shape, then the idea is sent to a software engineer that essentially starts developing the core logic behind this idea in order to ship and make the application accessible or the feature accessible to everyone. And, but before to ship it, in order to be confident on what you are releasing, you probably have to pass a security review. So that's why you have a role like the security engineer that will allow you to be confident in the release. And finally, once the application gets released, you probably have a data persona, like a growth marketer or a data analyst, that analyze the data that are collected through the app in order to generate insight and produce feedback to the PM in a way that the product or the feature itself gets improved. So these are kind of all the personas that, in a simple way, we can imagine are involved in the software development lifecycle. Now, with respect to these personas, Claude Code, the Anthropic's coding agent, augment all of them, providing several components that we are going to use today. So as I said, for the remaining part of this presentation, I'm going to put the hat of all these personas. I'm going to show you how you can use these Claude Code components together with Claude on Google Cloud in order to build and ship a very simple feedback application that at the end of the presentation we are going to use to rate my performance here. But before to start building, of course, you need to set up the Claude Code that we are going to use. And I'm so excited and so proud that we worked together with Anthropic to make this process of setting up Claude Code in order to use model on Google Cloud in a very simple way, in a very straightforward way. So you have multiple methods to use Claude models on Google Cloud in Claude Code, but the simplest one, the faster one, is using the application default credential, which automatically finds your credential, for example, the user one, and based on the environment that you're going to use. And as you can see in this representation, so recently, Claude Code also introduced this wizard that will simply allows you to detect your project and your region where the models are served, and check which models are available in your project, and like let you to pin them in order to start building your application. At this point, like probably you're familiar with this, and you're wondering, okay, but what is different to use just Claude code with Claude models? Why using Claude on GCP, on Google Cloud? So there are many reasons why you want to do this. So first of all, because you pay for what you use. So the usage of Claude models on Google Cloud is per token. So you don't receive a message cap. And also, if you're building an enterprise application that needs to go to production, you can always access to what is called provisioning throughput, which essentially will reserve some throughput for you in order to build this kind of application. The other important reason why you want to consider Claude on Google Cloud is, as I said, the setup is pretty straightforward using the ADC. You don't have an API to rotate or environment variable to set in some sense. So it's a happy journey with respect to this aspect. You can access model in your project with your own policies set. And also, like, the data stays in your project while you are interacting with the Claude code. And models are served in multiple regions. So you have global endpoint, you have a regional endpoint, depending on the availability that you need. And as a Google Cloud, talking about availability, we have very great availability service standards that will allow you to use Claude and on one of the most performing infrastructure that you can find in the market. So these are all some of the main reasons why you want to consider Claude on Google Cloud, especially in an enterprise context. So now that you have like few reasons of why using Claude on Google Cloud, we are ready to build. And so, as I said, I will start wearing the hat of a PM. So imagine that you just join the company, or maybe you are already part of the company. You have you want to improve our services. You want to implement a new features with respect to a particular product. What was happening in the past is that you have the idea, you go to a UI UX designer, and you ask him to prototype and visualize the idea. Now, with the Claude and Claude Code, what you can do is just drawing a picture like the one that you see here while you're drinking a coffee maybe in San Francisco, and then let Claude implementing the idea for you. So let's see this in action. So this is the Claude Code UI. Like, you will probably be familiar with that, and you are familiar with the Claude MD, which is essentially gives some instruction. Here we just say that we are a PM. We want to have, starting from the picture, we want to render a prototype of the app, the wireframe, that we are going to then use and pass to the UX designer. And in a few minutes, you can see how Claude was capable of rendering it, and just starting from a very simple picture or drawing that you did while you were drinking your coffee. So pretty straightforward. But imagine how much time you save in doing this, because compared to what you were doing in the past with the back and forth in order to get this first prototype of your idea. Okay, so at this point, the PM gives creates a prototypes and pass these prototypes to the UI UX developer. And at this point, he needs to implement a more solid interface in order to use it in production. So in this particular use case, what we want to create, it's at least 3 pages, from the landing to the thanking message page, and a dashboard that will allow me to show you in real time what can be the feedback that I will receive from the room. So in this case, there are many ways you can implement this, but in this case, I want to use an additional capabilities of Claude Code, which is the plan mode. So with the plan mode, what we do, we put Claude in a mode where it thinks before to, like it thinks and propose what it's going to do before to implement any code. And this is very important because it gives me like a degree of freedom of deciding to change something based according to my preference or according to some standard that probably I will get access through an MCP server using Figma, for example. So now that we have in mind what we are going to build, let's see this in action as well. So we started from the wireframe from the PM, similar prompt. I enabled the plan mode. And so as you can see, compared to before, in this case, I'm simulating receiving some instruction from Figma using a design doc. But as you can see, compared to before, it creates a plan of what it's going to do with respect to all the components that are defined in the slide. We look at them, we are happy, we accept, and code will implement all of them. And at the end, what we get is this optimized version. So as you can see, we start from here, and we get this. Very, very straightforward. But you can see how we are shifting from a prototype to something that can be used in this session in a very simple way. OK, so this is the part that probably every of you in this room, like you do every day, right? Let's wear the third hat, which is the one of the software engineer. And the software engineer, he received this front end, like all the components that I was sharing you before. And maybe he doesn't know anything, as probably some of you in this room, it doesn't know how to deploy this application on Google Cloud, right? So how you can do that? How you can, have this a clear picture of what are the components on Google Cloud that you need to use in order to deploy a very simple application like the one that I show you today. Luckily, it's not a problem because as a Google Cloud, we invest a lot of time to integrate with this large vibe coding ecosystem that now is growing around models. And in the last few months, we released two important components. So the first one is the developer knowledge API with the associated MCP server. And the second one is the Google Cloud Skills. So with the developer knowledge API, you get access to a fresh documentation from Google Cloud that can be directly consuming Cloud Code through the MCP server. And it will have Cloud Code to figure it out what is the best architecture, what is the best implementation to deploy a certain application on Google Cloud. This is very important because, again, what we are saying here is that you don't need to know like how to deploy an application on Google Cloud. You can just leverage Cloud Code and this MCP server that we expose now on Google Cloud side to build application like this one. So in this case, probably what we are going to do is that we are going to deploy the feedback API on a serverless function like a Cloud Run. We will connect with a web-oriented DB like a Firestore to collect the raw responses that we will give through the feedback app. And then because we want to have that data analytics part, we will build the implementation in a way that we can store those raw response in an analytical data warehouse like BigQuery. And in BigQuery, we will post-process and we'll consume this information in a dashboard, in a dashboard like the one that you can find in Looker. But again, you can build this using a Cloud Code in combination with the MCP server without you having a prior knowledge of how to do that. This, like the MCP server and the developer knowledge API that I just mentioned, it got paired with also the skill part. And the skill part is, if with the MCP server, you will be able to design the architecture, with the skills, you will be able to cover the single blocks of this architecture. For example, we release a simple skills that enable Claude to deploy on Cloud Run, to deploy an API on Cloud Run, or to connect like Cloud Run with Firestore. So it's more about the implementation itself rather than giving the overall picture. So once you get Cloud Code enabled with the MCP server of the documentation, the skills that I just mentioned, you can just directly implement the architecture that I was showing you before, and you can do this in parallel. So another components that you can use in Cloud Code is sub-agents. And as you can see here, we are going to spin up 3 different sub-agents, one for the API, one for the ingestion pipeline, and the other one for the dashboard. And you can parallelize the implementation of each of these components, just like you run a team sprint in your normal, usual development lifecycle. So let's see this in action as well. So here we are again. First of all, I just want to show you that we have enabled the MCP server of the documentation, and we have the skills, some of the skills that we pre-built. One time more, I provide a very simple prompt. The first step is designing the cloud-native backend. So it will it will provide me draft of the architecture. In this case, I could use, again, the plan mode, but for simplicity, I didn't. And then use the skill, one of the skills that I provide in order to implement the API. Let's say that we are happy with the API spec. Then we have the architecture, we have the API spec. The next step is running multiple agents in parallel in order to implement the three components of the app that I was showing you. So it's pretty quick. As you notice, Code it also managed the testing part after you finish the implementation, and at the end you will get your app, which is now ready to deploy on Google Cloud. Okay, so at this point we have the code of the app that is ready to be deployed. But because we are deploying on cloud and we want to open this up to a larger audience, we want to deploy it in a confidently. So this is when you want to consider to run a security review. Now, depending on your company, you can have different security requirements. So, for example, you may want to check if your application is solid with respect to the most common OWASP issue, or because you are deploying this application on cloud, and one thing that you need to consider is probably you will use what is called a service account, and you want to limit the service account when it calls a particular API, like the one related to reading and writing a DB, with respect to certain role. So you're sure that you are limiting what it can happen when the application runs some operation on the cloud itself. So again, these are just a couple of examples of what you want to consider in a phase like this one. And of course, this representation is a strong simplification of what can happen in the real life. It's just one of the possible scenarios that you can have. And you can see why it's also a simplification, because we are letting the security engineer not only to approve if the app is secure enough to be deployed, but it will also deploy the app in this case. But again, this is just a demo, so we have this degree of freedom. With that being said, let's run the final demo, and let's get the app running. So in this case, as you can see, I use a pre-built security review that you can find in Code. Very simple prompt also in this case. And what is happening is Code run the first test. Essentially, he double check that everything is aligned. He found like a possible issue, and he automatically fixed it. So in a way that the app now is secure. And once it is secure, it deploys the backend API, and it deploys the API itself. So what we get at the end of this, it's an endpoint with our app. The app is live, so I will quickly unlock my laptop, and I will ask the backstage to share on my laptop. So the app, as you can see, is up and running on GCP. For people that doesn't know GCP, this is Cloud Run. It's a serverless service that you can use in order to deploy app. And the app at the end looks like this one. So if you remember, I show you the original, I show you the feedback frame at the beginning. So what we can do now live, I can just give me a score. What do you think the session is going so far? Give me 5? Oh, okay, thank you, man. I really appreciate that. Okay, cool session. Let's be simple. I submit, and then in real time, it updates the number of response, the score, and the visualization. And also, just for fun, I build a feedback analyzer. So once I click this, it will run. It will call Claude on Google Cloud, and based on the feedback and the comments that you send, it will generate this summary. So pretty straightforward. I will ask to go back on the presentation. Thank you. OK. So at this point, we have the app. We collect good feedback. Thank you again, man. But the development lifecycle is still there. We have the last step to cover, which is essentially people that start using our app. If you saw, one of the KPI that I had on the dashboard was the response time. So how long is was taking you to just like providing a feedback. So these are the kind of information that you can use in order to, like, through this data, you can collect this data, analyze them, and generate insights in a way that they can be used in order to improve the application. Now, running, if you're new on Google Cloud, there are several services that you can use in order to analyze this data that comes from the app. So a couple of them, one, as I said at the beginning, is an analytical data warehouse, which is BigQuery. And for the reporting part, you have a tool like Looker. But again, as we said before, you don't need to know how to use BigQuery in order to analyze those data, as well as how to build a dashboard in Looker, because we also provide a MCP server for doing this. Now, for the sake of time, I'm not going to demo how to use an MCP server to query BigQuery or building a dashboard, but I want to quickly share with you where you can find this information in order to do that after this session, because we are going to release the code. So I will ask to shift back on my laptop. Thank you. So, OK. Loading time. So with respect to all the MCP servers that are available on Google Cloud, we recently announced the agent platform. So in the agent platform, you have services that is represented by the agent registry. And in the agent registry, you have the list of all the MCP servers that we natively support on Google Cloud. So for example, we have the developer knowledge service that I just showed you. And we also have the BigQuery MCP server that you can use in order to query the data that we just collected from the app. It's very, like, this registry is relevant because it tells you how to set the MCP server on your side, as well as it gives you some observability feature and the description of all the tools that you will find for the MCP server. So you know how Cloud Code will be able to use this server to query your data. With respect to the Looker part, also, like, we released the MCP toolbox of DB. This is an open source, like a model context protocol server, which include an integration with Looker. And it's very well, we have a very well documented quick start on how to set up with the Cloud Code and start using it in order to consume that data from BigQuery and build your dashboard. So I leave you this as an exercise. Like, we are going to release the code, so you can go home and integrate these two parts. It's pretty straightforward, but the dashboard that you can create, they're pretty powerful, and you will see how nice they can be. Okay, back to the presentation. I think I'm just in time, so time to wrap up. What I try to explain you today is essentially two things. So first of all, I was trying to, and I hope I did good enough. I was trying to show you how all the components of Cloud Code, including skills, MCP server, sub-agents, they can really speed up the process of software development, as well as how you can use Cloud Code with cloud models on GCP in a very seamless way. Like if you saw, we ran several sessions across multiple personas, and it was the experience was just straightforward. It was just incredible. So this is what you can get if you combine Cloud Code with cloud models on GCP. As I said, the code is going to be available right after the session. We have a great quick start, and we have a very well maintained documentation, both on Google Cloud side and Anthropic side. So I highly recommend to just go there and check out. And then I hope I cover everything, but if you still have questions or you want to provide additional feedback, just feel free to reach out. These are
Good. Okay, amazing. Welcome to the last workshop session of the day. I hope you have all enjoyed the very first day of Code with Claude. My name is Maya. I'm a member of our Applied AI team here at Anthropic. What that means is I spend about half my time developing our own first-party products and features, and the other half of my time helping customers develop their very own products, features, agents on top of our models. Today, I'm here to talk to you about how to build a proactive agent workflow with Claude Code. Can I get a show of hands? Who has used our routines feature inside of Claude Code? All right, some folks over here. Awesome, awesome. That's what I'm going to be talking about today. OK, so first off, a question for the group here. Who has tried to run Claude Code on a cron? Can I get a show of hands? Folks, put your hands up high. Awesome, awesome. Now, keep your hands up if you've enjoyed building all of that infra and maintaining that job. All right, we have one guy back there. We have one guy. Thank you. Thank you for your effort. Thank you for your work. We felt similar pain internally at Anthropic as we tried to develop proactive agents that run on Claude Code, and we decided to do something about it. So we believe that coding agents shouldn't wait for you to press enter to get started. Right now, Claude Code is a really powerful coding tool, but we want to take Claude Code and turn it into a really powerful coding teammate. A teammate notices when something breaks and does something about it. Right now, a tool waits for you to enter your prompt and actually press enter. So the goal of today's presentation is to talk about how we have created this feature called routines to take Claude Code from a tool today into the teammate of tomorrow. So today we'll be talking about 4 things. I'll go through some of the challenges that you folks have felt building proactive agents today. I'll go through this new feature inside of Claude Code called routines. We'll go through a real example about how we use routines internally at Anthropic to automate documentation creation. And then finally, we'll talk about applying routines to your own workflows. So I want to talk first through the challenges with building proactive agents today. We all know it's doable, but I want to talk about what's a little bit cumbersome with this. The first thing that's a little bit difficult with building proactive agents today is deciding where these agents should run. You probably don't want them running on your local machine because if you close your laptop or your laptop dies, your agent session is done. What that means is you'll need to manage things like hosting, data persistence, and authentication. Basically, you'll need to build a whole infra stack outside of your prompts, which is doable, but it's a lot of work and there's a lot of boilerplate code there. The next thing you'll need to do is figure out when to actually kick off these sessions and trigger these agents. Again, you can build things and build on top of cron, or you can do things like post to endpoints that you have to spin up. But again, there's a lot of infra that you need to build yourself here. Finally, the challenge with building proactive agents today is sometimes you want to be a human in the loop, but other times you want to be a human out of the loop with these agents. Right now, when you kick off a headless Claude Code session, it's often hard to figure out what your agent is actually doing in real time. There's no way to watch, steer, bound, or even resume your agent session. It's difficult to do that. So we wanted to address each of these three issues and build routines. Routines is a brand new feature inside of Claude Code. It's an automation where you can kick off a remote Claude Code session by only defining the prompt, what repos you want to connect it to, what connectors it has available to work with, and a trigger. Claude Code handles the rest. So there were three kind of main things we were thinking about as we went ahead and developed this routines feature inside of Claude Code. The first thing is that we wanted these agents to be always available. These agents, these routines run on Claude Code's managed infrastructure. And what's nice with that is that we deal with the hosting, the session state, and the connector auth for you. Nothing depends on your laptop being opened, and we deal with all of the cloud stuff for you, which I think is quite nice. The next thing is we want these agents to be able to work proactively with customizable triggers. You might want to kick them off on a time-based schedule, or you might want to work event-based. We have the ability to work natively with GitHub events, as well as your own custom events that you can post to webhooks and endpoints, with the event payload as context. Finally, and the last point that I think is really nice, is that these Claude Code sessions that get launched with these routines are interactive and steerable as if you were launching Claude Code in the terminal. Every routine is really just a Claude Code session under the hood that you can open, you can watch, follow up on, steer, and resume from web, CLI, and desktop. And so I want to walk you guys through a real use case that we use here at Anthropic internally. So the question for us and for a member of our engineering team is, how can we automate docs creation with routines? So just to add a little bit of data behind this, weekly PRs for Claude Code have gone up 200% since the beginning of the new year. This has been super awesome for our Claude Code engineering team. Their productivity is insane. This has been really awesome for you folks because you get new features inside of Claude Code very, very quickly. The one person that this has not been so awesome for is the one engineer responsible for maintaining our documentation across Claude Code and the Agent SDK. And so when routines launched, she was a super big fan and early adopter. And I want to walk you through how she set up a couple routines to help automate documentation creation for Claude Code and our Claude Agent SDK. So on my side here, I have the terminal open, and I encourage you all to open your terminal and launch Claude Code. And inside of the terminal here, I'm able to type what we see on the screen here, /schedule, and actually type in something that Sarah, our documentation queen, has done to actually set up this routine. So she went and typed in, once a week, please review all the new changes merged to main against our documentation repo and create a PR to update docs if you see any changes. I encourage you folks to think right now, what are some tasks that you do every day that would help if they could run on a schedule? Or if Claude Code could actually initiate these sessions for you? I encourage you to think about that. After kicking this off inside of Claude Code, Claude comes back and prompts me with a couple questions. It might ask, hey Maya, what time every week do you want me to actually kick this off? Or once I create a PR, do you want me to notify you in any way, maybe ping you on Slack? And once I answer these questions, Claude actually goes ahead and creates a routine that we'll view in a little bit inside of Claude Code on the web. But first, I want to walk through the three main decisions you'll need to make as you create any routine. The first decision is you'll need to figure out when your routine should trigger. What's actually the event, or is there a certain cadence that you want this to run? The second decision is what context or what information does Claude need to have to actually be successful here? Do you need access to certain docs, or does Claude need access to certain tools to ping you? Finally, the last thing to think about is how do you actually steer Claude in the session to keep it honest? How do you guide Claude to the output that you want? And so we'll dive into each one of these, and I'll talk through how Sarah, a member of our team, actually does this to automate documentation creation. So the first one is the trigger. When should this event actually run? So inside of routines, there's basically two ways to do this. You can have things kick off on a schedule on a time-based trigger. For that earlier example I showed you, this is how we do a weekly review of differences between our source code for Claude Code as well as our documentation repo. You can also have routines kick off on an event-based cadence. So maybe every time a release is cut, you can diff the release branch against the docs and see if there's any new features that you'll need to spin up PRs for in our documentation repo. Or maybe your engineers actually deploying changes and creating PRs might tag their changes. Maybe this is like a new feature. They could tag it with a label that says need docs. And you could actually kick off Claude Code sessions anytime one of these labeled PRs get merged. The next thing you'll need to think about is context. What does your agent actually need to know to be successful? Likely, you'll need to give it access to either one or more code-based repos. So for this docs example, we need to give Claude access to not only our Claude Code source code to figure out what new changes exist there, but also our docs repo, right, for Claude to actually create new PRs there. Next, you might want to provide additional context to these sessions. Maybe for this one example, I want Claude to have access to all of our existing marketing briefs. Maybe I want Claude to use similar language and verbiage that we use in other marketing materials externally at Anthropic. So maybe all of this lives inside of Google Drive, and I'll want to give Claude access to these files during the session, so I'll hook up the Drive connector. Or maybe anytime Claude creates a PR, I'll actually want it to ping me on Slack. So I'll give it access to the Slack connector. It's important to think about this as you're setting up the routine, because whatever context Claude has, that's the ceiling of how successful Claude will be. Finally, the last thing to think about here is steerability. How do we actually ensure the quality of Claude's outputs? There are a couple ways to do this. One thing that I think is quite interesting is to actually invest in agent-on-agent review. If folks have actually designed multi-agent systems here and have heard of the generator critiquer pattern, this is something that we borrowed here. You can actually set up one routine to go ahead and create docs PRs, and you can set up another routine that maybe triggers on that PR's creation to actually go ahead and leave comments on the PR before a human actually gets to it. Another option, we had emphasized it's nice to have a human out of the loop, but sometimes you actually do need to monitor these Claude Code sessions and maybe nudge Claude in a different direction. What's really nice, and what I'll show you in a second, is that you can actually open Claude Code on the web and you can view what's happening inside of a live session as if you would working with Claude in the terminal. You can ask it questions mid-session, you can push it in another direction. You can also resume a past routine or a past session and continue the conversation. Finally, the last thing we do, and what I think is quite obvious, is that we verify Claude's outputs. For this documentation example, we actually render the page that, or the documentation page that Claude has changed and created, and we confirm those outputs are what we expect. And so now I'll jump back into that initial routine that we've kicked off here in this demo, and we'll jump to the demo slides. Awesome. And so we can see right now I'm in Claude.ai, and I can go over to this left side panel and actually click on this code button. And I can jump into routines on this left-hand side. And I can actually click on this routine that I had created earlier. On the left-hand side here, you can see that it's connected to 2 repositories, our mocked up Claude Code source code, as well as our Claude Code documentation. You can see that this runs every Monday at 10 a.m., and it's connected to GitHub as well as Slack. These instructions here on the right-hand side, Claude generated for me based on the initial prompt that I pasted in and the questions that I answered. We can see here that this is a weekly documentation sync for our Claude Code fork. And I can actually go ahead and click on a session here. And I can see that these initial instructions are what gets pasted in for the very beginning of this Claude Code session. We can see that Claude has read these instructions and started by looking at the source code repository to see any changes, any recent PRs that have been merged, looked at our changelog, and compared that to what's inside of the documentation repo. We can see Claude's actually found some changes here and gone ahead and opened a PR for me. This is one example where you can kick off a routine on a schedule. Now I want to show you another example where we can actually kick off a routine based on a GitHub event. So here I've actually created a new routine, and I've already filled some of this in. I want to make another documentation automation routine, but this time I want this to actually trigger every time I create a new GitHub issue. So I pasted in some instructions here, basically to investigate the issue that this session triggers on, figure out if it's related to a documentation gap, and then if it is, and if you believe that this is a gap, go ahead, open a PR, and actually ping me in this channel. So I've gone ahead and connected our Claude Code documentation repo as well as our source code again, and I want to show you how I actually set up this trigger. Like I had mentioned before, there's 2 different types of triggers, schedule-based and event-based. And within event-based triggers, we have native GitHub events supported here, as well as the ability to trigger from your own code by sending a post request. So here I'll create a GitHub event trigger and trigger on issue opens anytime I open an issue inside of this Claude Code documentation repo. And I want this connected to Slack so I can send me a ping anytime I make a PR, as well as our GitHub NCP. So I will go ahead and create this here. And now let's make sure that this is working. So I have a new issue open here that I'm about to create inside of our Claude Code docs repo. So I happen to know that there are a few tools missing from docs in this new version. So I'm going to go ahead and actually create this. So I can see here that I've gone ahead and created that. And now let's refresh this page. And we can see actually that a new run has gotten picked up here. We can see that these initial instructions are the very first prompt. And we can see that this additional context from this issue are passed in as well. I happen to know that I actually already have another PR open for this. So let me just guide Claude to stop this session. I've already made these changes. And we can see here the ability to actually steer Claude in real time after a routine gets kicked off. Awesome. Now let's come back and talk about the different ways that we can use routines to actually automate your challenges as developers. I want to talk through a couple ways that we could turn common software engineering or developer challenges into routines with Claude Code. The first one I want to talk through is this deploy verifier. Maybe you have recently just deployed changes to a service, and you want to make sure that this service is healthy and you shouldn't roll back these changes. I want to think about this in 3 ways. First, what should my trigger be here? Second, what context is important to provide to Claude in this routine? And lastly, how do I plan to actually interact or steer this routine to keep Claude honest? I happen to know that my CD pipeline can post after every deploy, so this seems like a pretty good trigger to actually kick off this routine on. I can actually post to this webhook that we support inside of routines, and this can actually kick off my Claude Code session. In terms of what context I think is important to provide Claude here, I can think of a couple things. One, it's probably nice to give Claude access to the source code for the service that we recently deployed on. Next, it's probably important to give Claude access to monitoring tools. Maybe that's Datadog, maybe that's Grafana. I don't know what you folks use, but likely helpful to give Claude access to these monitoring tools. And maybe if something goes down, I want Claude to alert me. I want Claude to ping me on Slack or send me an email, or maybe even send me a text using Twilio or something like that. These are some of the connectors or the tools that I would give Claude access to inside of this session. In terms of keeping Claude honest or actually steering my session, maybe I'd start by having Claude run an investigation for me and giving me an eventual go or no-go decision to actually roll back this change. I could jump into Claude Code on the web and actually view and read Claude's analysis for this session. Then maybe I can continue to work with Claude if I actually think that this should be rolled back, and actually use Claude to help me roll back a change. Maybe eventually, as I watch Claude work more and more and trust its decisions, I can let Claude roll back the change itself if based on the monitoring data it has access to, if I deem that that's the right decision. There are other challenges, like maybe you want to build an on-call investigator, or maybe you're actually a PM and your job is to go through a lot of issues inside of your backlog. Maybe that's GitHub issues, maybe that's posts inside of a Slack channel, and maybe you want to kick off a weekly job that actually reads through all of these issues. Maybe it's kicked off on a time-based trigger, you give it access to GitHub and Slack and wherever your issues live, and you use Claude to actually help you prioritize and maybe open PRs for the most important issues. Okay, my final takeaways here. Proactive agents beat reactive agents. We want Claude to go from a tool to a teammate. You can move from an agent that is waiting for you to actually press enter and create a PR to an agent that reacts to problems and opens a PR itself. We built routines so you don't have to focus on maintaining all of this infra, but instead you can actually concentrate on your domain and process expertise. This is what routines handle for you. And finally, I encourage you to get started with routines today. You're a single/schedule command inside of Claude Code away from creating your very first routine.
Hey, my name is Kevin. I'm an engineer here at Anthropic, and today we'll be learning about how to build agents that remember. Today we're going to talk a little bit about the base case with agents today, which is that they're isolated, and this kind of limits their usefulness in a lot of real-world workflows. We'll look at how we can actually solve this problem with our new agent memory stores feature that we've launched. This will give agents access to a live memory store that they can read and write to over multiple sessions. And then we'll look at how we can improve these memory stores over time using a new feature that we call Dreaming. And then finally, we'll get to see how all of this ties together with both our CLI and also our awesome console interface. So in the previous workshops, I think we've learned a little bit about how Claude Manage Agents has these concepts called an agent, environment, and a session. In this workshop, we're going to add 2 additional concepts here. The first one here is a memory store. So a memory store is a persistent file system-like store that that attaches as a resource to sessions that you create, and it gives agents access to, it gives agents the ability to read and write information across sessions. A dream is an asynchronous job that runs in the background. It looks over an input memory store and a bunch of your previous sessions that are represented as transcripts. And then we run a harness over them to distill new information that maybe the original agents missed. We do things like fact checking. We also organize, consolidate, and deduplicate information so that your memory stores don't grow unbounded over time. So also, in case anyone in this room has not already downloaded the workshop repository you'll need for this, here is the URL. I'll give a few seconds for folks to just grab that. OK, so let's kind of like talk a little bit about the problem today. So when you create agents on Cloud Managed Agents today and sessions, most of the time you're creating one session at a time, and these are isolated, right? The agent doesn't remember information from the past, and it doesn't transfer information to future sessions. So I want to kind of like take us through this base case today. So if I switch over to my computer, I'm in our workshop repository here. Hopefully everyone can see this in the back, but I've just run the Bootstrap script that we've included in the repository. And what this has done is basically created some seed information for us. So we have an agent, we have an environment, and we have a few like previous sessions that talk about things like the keynotes from day one, as well as a previous workshop. And so what I'm going to do from here is actually go ahead and start walking through this guide with you guys. Feel free to follow along on your computers. I'll be using the CLI and then also showing kind of the console interface for each of these steps. So first, we're going to create a session that basically tells it some new information. So I'm going to copy this command here. And as you can see, we are creating a session with the agents that we've created before, with the environment ID. And we've given it a title here of just like write test with no memory. Great. So now that we created this session, I'm going to quickly switch over to my console here. And you'll see that, let me just move this over. You'll see that the session shows up in console. It has a status of idle, nothing running yet. So then we're going to switch back, and then I'm going to send this session some new information. So once I copy this. And what I'm doing here is sending a first user message here with information about the CMA talk yesterday, naming a few keywords like multi-agent orchestration, outcomes, and memory. And I've also just given it this URL example that I took notes and uploaded them here. So if I switch back over to my console, we should see this event pop up. And what we sort of expect the agent or the model will do here is it'll just respond and say, like, great, thanks for the information. Not sure what else you want me to do here. So we'll give it a sec and maybe folks to catch up. Let's see if we get a little refresh. Sorry. Yeah, so it looks like the model responded here. Just collapse this. Yeah, it's basically saying, OK, great, thanks for telling me this information. So then if we go, sorry. This is using, I believe, Sonnet, the agent that was created at the beginning. Yeah. Cool. So if I go back here to my workshop here, we're going to create basically a second section that's kind of the read test. So I'll go through these steps a little bit faster. And then, again, I'll send it a message here that's this time I'm going to ask it for information about the stuff that I just told it. And if I go back to our console here and check out the other session that should have been created, we would expect the agent to basically say something like, yeah, I don't really have access to this information. I can help you in these various ways. Great. So that's effectively the base case today. So if I go back to the slides real quick, this is just a quick recap of what we did. We told it something, asked another session about it later. No information is transferred between the sessions. So how do we solve this problem, right? Just like in humans, we've introduced the sort of concept of memory. And again, a memory store here in the Cloud Managed Agents platform is a file system-like store. Under the hood, you can create as many memory stores as you like here. So you don't have to necessarily restrict a memory store to one organization. You could create it per user, per workspace, et cetera. It's up to you to kind of define what the boundaries of the memory store are. And then under the hood, this memory store gets attached as a file system to the session container. And the model has tools to read and write to it. The actual interesting thing here is that we've actually mounted it as a file system because it's such a powerful interface for the model. You can use things like bash to like explore the file system. It can use grep to kind of search for keywords. It can also read files and do a bunch of like really powerful things that make it much more useful for the agent. So I'll switch back to my computer here, and we'll walk through kind of how to create a memory store. So first things first is actually creating it. So I'm going to copy this command here. Feel free, again, to follow along on your computers. And the kind of parameters that you need here are mainly just like a name. So I'm calling mine CWC memory. You can give it a quick description. And then I'll show you also in console later that there are 2 additional parameters that you can set here, but let me just follow through with a simple example. Once I create this memory store, you can actually see it in console under Manage Agents, Memory Stores. And you'll see that it's active. You can actually click into it and view essentially a file system viewer of what's currently in it. Of course, there's nothing in it right now. Additionally, we offer functionality. We offer the ability for you to like manually add memories. So you can create like a file under a specific path, add some content, etc. If I go back just a brief second and talk about creating a new memory store, there's actually 2 sort of additional parameters that you can set on the memory store when we actually mount it. So if I go back to the repository here, the next step, once you create a memory store, is to actually use it with your sessions. So I'm going to, again, copy a few of these commands. So the first one here is basically just giving us the shape that we need to pass the sessions API request. I'll paste it in our terminal here so we can see it better. So again, the memory store here, you just pass in a memory store ID. And you can also give it a prompt around that will steer the agent to read and write specific information. So you might want it to focus on maybe like a specific link or a specific like area of focus on. Let's say you're making like an investment agent, right? You want to focus on specific things to remember for the future. So you can do that with a prompt parameter. Additionally, there is an access field that defaults to read or write. You can change that to read only, which will make it so that the session and the agent will only be able to read from that memory store, cannot update it. So once I run this, you'll see I have created a new session in console. And this time it'll have a memory store attached. And then if I send an event here this time, we'll just basically repeat the test that we did just before. So let me grab this. Again, same text as before, we're telling it new information. And hopefully we'll be able to observe a different behavior this time. Yeah, so clicking into, if you click into the session details, you'll see the information that I just gave it. And now the model is like first looking at memory to see, okay, was there anything that like I need to remember for this conversation? And now it's going to actually like, of course, there's nothing in our memory store. So now what's going to do is actually save the content that I told it to that memory store directly. And it saved it under this like sessions.md file. And it's great, telling me that what it did. So then if I go back and do that same test that we did before, this time I'll just copy both. Sorry. Again, where this time we're going to create a new session with the same memory store that we were just using. And we will send it an event here asking it what are the things that it found or it learned from the CMA talk. Once again, going back to our console UI, we can see the recall test running. And as we would expect, the model is now first looking at its memory store to see if there's any information. And again, it's now using grep to find any sort of keywords here. It's looking for CMA. And great, it found like a lot of information that we just told it from a previous session. And now it's able to answer my question, right? And this is like, of course, a very simple example, but this illustrates kind of the power of memory. And this is like something that was kind of difficult to do before, right? I'll give a quick pause in case anyone's straggling. OK, great. So what else can you do with a memory store here? Well, we actually offer additional sort of endpoints that allow you to manually inspect the store itself. So I'll use the CLI here, but for instance, you can list all of the memory files that are in the memory store. We can do that. There's also each memory files in a memory store are also versioned. So anytime you make a change to a file, et cetera, there's a new version that's created, and we offer a set of endpoints for that. And then I can also kind of take you through the memory store UI. So each memory store you create, again, is here. And if we go back to our kind of file system view, you can actually see the files that it created. There will be a directory structure here if Claude is creating kind of subdirectories to organize memory files. You can actually edit these memory files directly if you wanted to. So for instance, if Claude wrote something that was incorrect, or maybe you just wanted to add more information, you can do that. And again, as we saw before, you can add additional memories to a memory store. OK, so I'm going to go back to the slides real quick. And as we just talked about, this is how you create a memory store and then mount it on a session that you want to use it on. Again, it's up to you to kind of decide which of your sessions will use memory, which ones will not. We also saw how you can list memories and see what's currently in a memory store. And let's move on to talk a little bit about dreaming now. So when you have agents that are reading and writing to this memory store over time, we've noticed that oftentimes they can start just kind of dumping information to that memory store. So it'll start writing maybe every task that you ask it to do, it'll maybe record its information, right? And over time, your memory store is going to grow, right? And there's no real process before that would allow you to sort of organize that memory, maybe check to see if anything was stale, and consolidate any duplicates, right? And so this is where dreaming comes in. Dreaming is a batch process that runs, again, asynchronously. You launch it using our API or through console, and it'll run a new dreaming harness that we built that is a multi-agent setup. It will look over each of the input sessions that you've given it. So you specify an input memory store that you want it to dream over, along with a group of transcripts that you think might help or enrich that memory store. It'll look through each one, do, again, fact-checking, enriching with additional details, maybe dates, specific identifiers, and then it will also organize those memory files and see if there's any duplicates, anything that can help fix, so that and it'll produce an output memory store such that in the future, when you attach that output to additional sessions, it will hopefully increase efficiency, of information retrieval. It also hopefully increase the intelligence of the agent. So let's take a look at how this works. I'll again switch back to my computer and we'll walk through it together. So to get started with dreaming, basically, you'll need to actually create the dream job. And I'll go through a little bit of the parameters here. So the model here that we're choosing is Claude Opus 4.7. You can choose between Opus 4.7 or Sonnet 4.6, depending on kind of the level of quality you want, as well as maybe token costs. It takes in 2 inputs. So you'll need the memory store that you want it to dream over, as well as a list of session IDs. So this is up to you to decide. You can maybe dream over daily and dream over maybe 10 sessions at a time or 20, right? It could go all the way up to 100. We're also looking to scale it further beyond that. Optionally, you can also provide the dream job some additional instructions that you might add. So we provide it with a default prompt that does a bunch of things. If you wanted dreaming to, for instance, specifically fix a few things, like maybe you're working in a domain that requires very specific details, right? You might ask a dream job to really focus on, hey, make sure you backfill these details so I remember for the future, right? You can also you can also steer it to maybe organize files a bit more, I want this specific structure in my memory store, please do that. So let's actually go and run this command here. Great, we'll get back a dream ID. And then once again, I'll go back to our console here. And so dreams are under, again, manage agents, dreams. And once I create the dream job, it'll start with pending, but it'll start running pretty shortly after. And you can actually see the status of the job both in console and through the API. I'll show both. But in console here, you'll see the input memory store as well as a token count. And generally, like a dream job can take, depending on the size or the number of transcripts that you give it, it could take anywhere from a couple minutes to hours at a time. And that's really the benefit of doing it asynchronously, right? Like this is not something that you want to do live while your agents are working. And we'll just give it a minute here to run. As you guys can see, as it's running, as the harness itself is running, we're updating the token count for you so you can track its progress over time. The other really cool thing here is that Dreaming is actually built directly on top of Claude Managed Agents primitives. So you can actually see that we are creating a session for the dream job itself. And you can actually click into it and see exactly what the dream is doing. This offers a really nice amount of observability, and so you can diagnose issues potentially. And so you can see the prompt that we give it. There's a lot of details here that you can explore on your own time. But under the hood, the Dreaming harness itself is launching subagents to look over all of the transcripts that you've given it. And each subagent essentially has a system prompt that tells it what to do, look over it, and the orchestrator is responsible for just making sure all the agents are running and kicking them off as they go. So we'll give it another minute to let this run. Another thing to call out here is that while we don't actually touch the input memory store at all that you create, so this is a non-destructive process, what we actually do is we will clone your input memory store into what's called an output memory store. And the dream job will be writing basically to a new memory store such that any edits that are made are non-destructive. And then we'll see down the line how you can utilize this output memory store in your future sessions. Generally, this takes about a minute or so, depending on how fast the job runs. One other thing is that you'll see that I'm sort of checking on the job periodically as it's running in console. When you do this programmatically, we offer an API that allows you to just essentially query for the dream job, and it'll have a status, so you can pull for the status. Great, so it looks like it just completed. And the cool thing here is that in console, we actually show you a diff of what it did. So you can see Dreaming here, it created an index file. This index file has sort of these slugs that reference the various memory files that a future agent might need. And the main goal of this is really just that future agents, it's a lot more efficient to kind of look at an index file and quickly grok what it needs to go look for instead of maybe doing a wider grep. Additionally, it's actually adding additional information that was not present in the first couple of sessions that I created. So it's creating this event logistics file that gives the whole schedule of Code with Claude, a bunch of names as well. And again, schedule for day 2. And you also see that it actually kind of reformatted the memory file that I created in a previous session. So this time it is adding, again, a slug, a description of the event, some additional metadata, and again, adding more details. And generally, we find that more information actually really does help future sessions. And if you think about it intuitively, while an agent's working on a task currently, it's kind of hard to predict down the line what it might need, right? That's just generally a harder prediction problem. So it's actually good to kind of write additional details down that a future agent might remember. And Dreaming can always go back and remove stuff that is no longer needed. And if I go to the output memory store here, I'll just click on it. Again, you can see all the files that I created. It's another good way to sort of see what's going what Dreaming did. And if you wanted a human in the loop kind of review process, this is kind of where this is super helpful. Human can kind of go in and see if the dreaming, harness mating, and mistakes. OK, great. Just going to switch back to the slides real quick because I want to show a diagram. Yeah. So again, under the hood, this is sort of how dreaming works, right? This is a multi-agent harness. We have an orchestrator that is mainly responsible for spinning up subagents. And again, we spawn one subagent per input session that you give it. And kind of the reasons behind this are we actually kind of want dreaming to be exhaustive by design. If you give it 100 transcripts, you want to make sure like Claude is looking over all the information to make sure it's not missing anything, right? Great. So now let me switch back to my computer again. And this time, I'm going to actually like walk through how we might use this in a future session. So once the dream is done, you can actually go and grab the output memory store using this. So again, we're just retrieving the dream resource with the dream ID that we created, and then querying or just grabbing the JSON memory store ID. Great. So this is the memory store. And again, you can look through what memories it created. And now we'll do this sort of test again that we did before with the 2 sessions. So I will create a new session here. And you'll notice that this is now using the output memory store from Dreaming. Once again, we'll send it an event here. We're just asking it what sessions I attended, what resources do I have links for, and what follow-ups did I flag. Once again, going back to the console, it's really a great way to visualize what's going on here. And you'll see that this time, when it's reading from memory, you'll see all the stuff that Dreaming did, right? So the index, the event logistics. And it's now reading it's starting to read the index first. OK, great. Now it knows I'm going to go straight to the sessions file. It's being a little exhaustive here, just checking for event logistics. OK, great. Let's see what it came up with. So I think you can see I'd have to go back and show you the previous session. But this time, I think there's a lot more information here. So it gave me a recap of all the sessions I attended. It's giving me timestamps now about like all the sessions that were planned for day 2, as well as like the resource links, right? I think this kind of showcases again like how Dreaming can really enrich information that is transferred between sessions. And then optionally, at the end, if you're really happy with the output memory store here, you can go ahead and actually retire the old memory store. So this won't affect like your previous sessions. It just means that it will keep you the number of memory stores in your organization down to a reasonable level. Great. So I'm going to kind of switch back to the slides here. And talk a little bit how you can kind of view sessions, memory stores, and Dreaming as 3 composable layers here, right? If you think of a session as an isolated instance of an agent running, it's typically one conversation thread, typically ephemeral, right? A memory store augments that. So now you can connect information between your sessions across multiple sessions, right? And then finally, with Dreaming, you're now organizing, enriching, and improving your memory stores over time, so that as you scale up the number of sessions you have, and as you scale up the information that it's being processed through those sessions, your memory stays at a reasonable level. It's manageable. It doesn't blow up. Also, it checks for things like staleness to make sure all the information is up to date. Right? I wanted to highlight some of the maybe good questions that I got from the audience here. So one of them was around generally like sort of what is the like token usage of this feature like? So as I said before, like I think by design, we actually do want it to be exhaustive, so we do expect it to use a lot of tokens. The nice thing here is that because most of the processing is agentic, most of the tokens are actually cached. So we're expecting like about a 95% cache hit rate on like most Dream sessions, right? And additionally, we are exploring like other ways of offering this at lower costs to you. So example of this would be like similar to our batch API, we could offer things at a 50% discount by scheduling it at different times. Other additional like token usage controls include like switching the model, steering the prompt a little bit more, also providing more like just general budgeting of tokens. Great. So I think we're just about winding down. So I'm going to quickly kind of go over again for the folks remaining in the room, like what we went over today. So again, we talked about the problem that most agents face today, which is like, how do you remember information across sessions? I think this is a pretty like well-established kind of problem now. And we talked about how memory is kind of the first step to addressing this, right? You give agents access to something where they can dump their information, read from it, et cetera. But we also saw how this creates a problem where memory stores can grow unbounded over time. They can grow disorganized, information can grow stale, et cetera. And then we saw how dreaming can be used as a way to mitigate this problem, right? So we take another set of agents that their entire job is to improve that memory store for future use.
Is what are some of the lessons I learned in helping Claude Code and Cowork kind of like grow, and as we're building out this team, and kind of like what things and it's interesting, it's lessons I learned even if I think about my time at Meta or even Microsoft, but even Anthropic. Like it's funny, I did this slide deck maybe like a month ago, and already I've had to change some of the content because, for example, when I started this deck, there were no routines, and that even like that way of working was different for me. And so, yeah, like we really want to, like I want to kind of cover 5 themes that I've noticed. One, which is the bottlenecks have moved, they've shifted. And so when bottlenecks shift, what are then some of the team norms that we had to rewrite within the Claude Code team? I also wanted to share a little bit about all these team norms we had to rewrite, how we rolled them out, and also what are some of the proof, some of the, you know, like some signals that I get of, oh yeah, we're trending in the right direction. And it's always going to be important for me to kind of look at to see, is it still serving us trending in the right direction? And then I'll end it with a few kind of like questions that I still have for myself, and then also some suggestions for you to maybe take an action item back to your teams to have conversations together. So with that, the first section, the bottlenecks have moved. I call it the shift. But you'll probably hear me repeat this kind of subtitle text a lot, which is, what served you prior may not serve you any longer. And when actually, even when I think about experience, whether it was like an Anthropic or Meta or Microsoft, the constant growth mindset is just a muscle that has served me really well. And especially right now when the rate of, I don't know if y'all are feeling it, the rate of change is just a little bit crazy, right? Like I remember the first time I started doing some vibe coding was last year, and it was still making some bugs, and I'm like, why are you using constants everywhere? That's not good at engineering practice, and now it's just become so much more capable. But that's what I'm seeing as this interesting shift of when the bottlenecks moved. How do you think about adapting in terms of everything else around that bottleneck? So maybe y'all are feeling this too, but like for years, engineering bandwidth was the expensive thing. Like coding throughput was really expensive. And when you think about all the processes we have of shipping software, a lot of it was around, hi, welcome, there's a chair. Take away those reserved tags. There's no one sitting there. There you go. And there's another one right here, sir. Welcome. But yeah, like all of that, like even when you think about how we used to do planning, like remember we used to do like waterfall and then agile, everything was used to be because engineering bandwidth was really expensive. Actually, I'll take a little segue here. This is not the first time like when you think about our industry, we've always had to adapt. Like I'm gonna put you all in a time machine. Come back with me all the way to the year 2000s. That was when I started my career. I worked on Visual Studio, and we were shipping Visual Studio 2005. And I kid you not, in those days, if folks remember, we used to ship software on like CD-ROMs. Before CD-ROMs, it was actually floppy disk. And so I still remember at VS 2005, there were really hard deadlines. We had to hit those deadlines because we had to get the software to the manufacturing lab, to print on the CDs, to put in the boxes, to ship in the stores. And so when you even think about that, when we were able to distribute software online, that also changed. how we ship software. And so that's what I'm finding really interesting of this new shift that I'm seeing is engineering bandwidth. It's no longer the expensive thing. So for example, on the Claude Code team, for sure, coding is rarely the slow part anymore. And I would say it's not even that it's not the slow part, it's just also the throughput has really, really increased. So it's not only like, yay, we're all getting to build more, it's just the amount that we're generating has also changed a lot. And so what we saw was, when your bottlenecks shift from kind of the coding and the actual act of typing, like if you remember, it used to be writing code was expensive, or writing tests, or refactoring. I remember all of these conversations of, we have to schedule some time to do refactoring. Oh, but we have to do product work, and this is expensive. When are you going to find that time to do it? All of that has shifted now. That is no longer the bottleneck. And so when that happened, sometimes I noticed that bottlenecks end up shifting towards other areas. And so what happened? Like, for example, verification, review, cross-functional partners, security, because coding is no longer the bottleneck, and also we're doing so much more of it, these are some of the new bottlenecks that we're seeing. So it's really always us asking, is this code correct? Who reviews this code? That's like probably one of the top questions I get from all fellow Eng leaders, like, how are humans keeping up with how you guys are doing like code reviews? And interestingly, also, how is it maintained? Because now it is also a lot easier for us all to generate a lot of code. So also thinking about that maintenance cost too. So with that, these were some of the processes that I noticed quietly stops working. And I love that phrase, quietly stops working, because I don't know if you all, like, a lot of times we all put in processes, hopefully for a reason, right? Like we're thinking, hey, there was a gap here, we want to improve. But what I've found over the years is rarely do processes kill themselves. We tend to just layer more and more and more processes on. Like I remembered on one team, we had so many SLAs. Like there was a P0 bug SLA, a high priority like sub review incident. Anyways, there's so many SLAs. After a while, I'm like, oh no, we need to stack rank priorities so that all the engineers knew which SLA was going to be even more important. And I remember even at that time, I thought, hey, we should start thinking about what things we should defrag a little bit. But yeah, so these are the processes that might have served you. If you remember, again, it's that line of what may have served you may not serve you any longer. But like the planning norms. We used to spend a lot more time, pre-planning because coding time was expensive. Code ownership, there used to also be a lot of questions of who wrote this code, who owns it? That's a little bit of an odder question now. Code reviews, we'll get into a little bit. Team makeup is interesting too. It's not only like roles are blurring, right? Like, so like engineers can also now have AI to help augment non-engineering roles. My non-engineering partners are also all shipping code. So what happens when roles start blurring and you don't have those, like the silos anymore? And then that also goes to knowledge share. Knowledge sharing and onboarding and everything is another signal that we're noticing at Claude Code. How we used to do things change a little bit too. And so, in the first section, we talked about the shift. So within the Claude Code team, what are some of the norms that we have to rewrite? So I want to share some of those with you, and then hopefully some of them will resonate with you or you might find helpful. And so number one is code review, like human judgment of like who actually needs it. And we'll kind of go through all of these, but like the onboarding has also changed, how we do planning. You've heard me talk about like planning a lot. Hiring, especially with roles blurring and kind of team makeup, how that has changed for us too. And also org shape. That's kind of one of my favorite spicy topics. I'll share that story with you all when I started proposing that at Anthropic. I love my recruiting partners, they're awesome, but I remembered, one recruiting partner really did think I was crazy. So I want to share that with y'all too. So how have planning changed, but also technical debates. Planning, we do a lot less of it. Like I would also, and also the timing, I call it like JIT planning, almost like JIT compiling, because even when I first joined, I'm like, don't we need a 6-month roadmap? And we put some effort in, we wrote it, it was pretty good for 3 months, and then I came back over the new year, and so many things had changed already. So I realized, wow, 6-month roadmap just seems like a little bit too long. So again, it's how do you make sure you kind of like do just the right amount in the right time? Because again, prototyping and code generation is just not the bottleneck that it used to be. The technical debate one is a fun one too. So in technical debates, code wins. I'll share with y'all when I first joined the Claude Code team, I wanted to do a refactoring. I wanted to like get to learn about the code base. And me and Boris had a healthy technical debate of, which way to go. And I almost leaned into my old toolbox. I almost tapped him on the shoulders, go, let's go to that room and have a whiteboard and we can, and I'm like, wait a minute. Nowadays, I can just generate all the different options we've been discussing. I generated 3 PRs. And the cool part about that for the technical debate is I really cared not only about the implementation of the API, but also the impact to all the callers into the API. And so when I can have Claude help me generate the 3 different versions, it allowed us to have a debate of not only implementation, but also impact to the colleagues. So I think that's another really interesting kind of pivotal change. So yeah, when building is cheap, arguing expensive, again, how does that shift your team norms a bit? I do want to call out, this makes it even more important to make sure you set up team culture for how you think about alignment. For example, what totally won't fly is because code is, so much faster for us to generate. It shouldn't be like the last person who check-in wins, like I'm going to stay up at 3 p.m. to submit this PR, set up a routine so that I get the last word in. So definitely a no-no. That makes it even more important to make sure you have good team culture. They can have open, honest, technical debates, but also a good team alignment. So I talked a lot about kind of what we reduce and planning. On Claude Code, we definitely have reduced the design doc before every code ritual. I would say certain teams and for definitely certain scenarios, it's still really important to think about design docs, especially as we're doing kind of async discussions. But on Claude Code, most of our discussions is instead of a doc, a PR. That's kind of one of the words we have of, hey, we've got an idea, go prototype. That's the other thing. We don't really do a lot of product reviews because the landscape is changing fast. So let's prototype, let's actually get a lot of internal ants using it, and I'm really a big fan of shipping it out to all of you and then hearing all the excellent feedback so that we can really, and again, that has changed our planning ritual to be a lot less design docs, and mostly discussions are in PRs or prototypes. So we reduced that, but what did we double down on? And I think this is an area where we actually need to do more and continue being better. It's the verification. Because again, it's the throughput is different. And there are new ways to break, so how can you scale out? And I call it kind of shift left. In the old days, you would get code out, and I would love for me to find bugs before any of you find it. And what's better than me finding a bug is actually what I call shift left, more automation, so we catch it earlier to the source. So that is something that I think we need to continue to double down on. And the other thing that's interesting is also because roles are blurring. For example, my designers, I would love more confidence that when I checked in this code, I don't break something. I remembered I fixed a bug in Resume or something, and the next day I was catching up on Boris's, threads, and I saw someone tag him of, I'm noticing a bug. I remembered having that sinking feeling. I don't know if y'all have did I just catch a bug? So because of the throughput, I just really want to make sure everybody, regardless of roles, just has a lot higher confidence for the change that they're putting in. Who made this change? And so my advice here is, again, because all our PRs are assisted by Claude, it's a little bit of an odder question. And so for us, what is more helpful than just that question is what I call double clicking into it. So in the old days, when you used to ask, who made this change? What question are you really trying to answer? Are you looking for who caused this regression? Definitely don't want to blame, but just want to know who was the last person that touches code that might have caused this break? Or are you looking for an expert to answer a customer question? Or are you looking to gain context? So whatever is that double click question, also think about, is there a way you can automate? It's funny, I mentioned I had to change a slide deck. When I started this talk about a month ago, part of my every morning is I would bring up my desktop code and go into, here's a customer feedback channel. And I kind of want to ask it to summarize. And that was just a morning ritual I would do with my morning cup of coffee. Now it's routines, right? I can set that up, and then even better than what I had done before, which was I would kick it off. I'll be with my morning cup of coffee, I always get to kind of a pretty good overview. So that's my point of code ownership is a little bit more fuzzy, but on the flip side, double click to what question you're really trying to answer and seeing how Claude can actually help you with those. How do you keep up with code reviews? So I'm really glad if y'all saw the keynote this morning, Kat talked about it. We definitely leverage heavily Claude code review. Now what's interesting is going to be, where do you trust Claude? A lot. But then where do you still want a human? And so for sure, and actually Claude also, as Kat showed y'all, the Claude also does a great job babysitting PRs, and so we definitely have Claude handle all the style and lints and PR feedback requests, even like maybe catching some bugs and fixing them before it even does the full commit. And also adding tests. That's like really what we've leaned heavily into Claude for. But where I still definitely want a human is that expertise. It's all about trust but verify. So for example, legal review, I always definitely want to make sure I'm getting my legal partner still. It's, you know, like risk tolerance. So for example, trust boundaries and security sensitive code, I still want to make sure I'm pulling in the experts. The other area, which is kind of fun, is also that product sense and taste. Like I remember one of the fun things I like to use Claude for is I like to decorate Claude for the holidays or the seasons. And I remember last holiday, I wanted to update Claude in the terminal to, you know, give them a little holiday theme. And I asked Claude Code, can you turn Claude into a snowman? Claude wasn't that good at ASCII art in those days. And I remembered asking, that's where product sense really comes in. I asked my design partner, hey, can you review this for me? And she gave me such good feedback. She's like, you turn Claude into like the Mr. Peanut character, because I was trying to make him snowman. I'm like, okay, I'm gonna do something more simple. So Claude was like ice blue with snowflake, but keep in mind kind of that product sense as well. Which leads me to, what should my team makeup be? Because roles are blurring, Claude is augmenting. I'll share with you on Claude Code, there's 2 profiles for engineers that I've really heavily indexed on. One are like creative builders with product sense. Usually you'll see these are, you know, the dreamers. There will be a big sense of curiosity. You're really passionate about, oh, here's a problem. Maybe I could, you know, ship a product that solves that problem. But then there'll be a lot of iteration to make sure you're delivering a delightful experience. The other one is deep systems expertise. So when I first joined Claude Code team, I noticed actually we were pretty good with product generalists and creative folks, but we were missing folks with like distributed systems expertise. And when you're building things like Claude Code Remote to ensure we can run Claudes everywhere, you really still need those expertisers. So I would say, you know, whichever software engineering lead you're part of or supporting, think about those hard parts of where you might want to continue to still double down. But for sure, what I index less on is raw throughput, because thanks to the models, we're just a lot more efficient. The cross-functional gaps is another interesting one. So for example, I remember I wanted to do an update to how we do survey responses, but I didn't have a dedicated content designer to work with me. And I'm an engineer, my writing skills are quite terrible. I struggle to write things in a short and succinct form. I don't want the surveys to like, you know, overload you all in the terminal because every line space is really important. But that's where Claude, like in the old days, I would be, who is a group of content designer I can work with and I can kind of give changes back and forth. But now Claude has really helped me to augment that role and was a really good content design partner for me to kind of like make sure the verbiage is good and succinct. And on the flip side, like I say, our PMs code a lot, which is really fun to see. So again, like I would say with Claude, like you have non-traditional coders now being able to do more engineering. But you also have engineers that we can also now lean in to do things that was traditionally, you know, like not on the technical side, but more for the content or design. So it's very interesting. I found that Claude and AI has really augmented roles kind of like all around. This was a spicy one. So I remember when I first joined Claude Code, everyone's like, okay, you're gonna grow the team by a certain amount. And I could tell recruiters were still using the typical, you know, 10 ICs to 1 manager, and then how do you start thinking about nesting? I really have leaned into keeping it really scrappy. And actually, maybe I would step back too, whether it's at Anthropic or Meta or Microsoft, whether it was like Visual Studio or Facebook Marketplace or AR, VR devices or Claude, like what I have found to really help me ship great product is heavy, heavy, heavy dog fooding, especially for leaders where nowadays it's actually fun. I can still be in the code, but for a while it wasn't. And when you can't get your hands on the code, I would always make sure I make your time so that I'm actually using my product days in, days out. And so that's why I wanted every manager in Claude Code to start out as an IC first. And also like earn some street cred with the team and really learn how to be an effective engineer. And then I really structured the org to be as flat as possible because I want us to be super agile. This was just, my recruiters had some concerns because I remember they said, you want to hire managers and they will start as an IC first? No manager will be interested in that. I'm like, well, this is what dog fooding on the Claude Code team's about. This is what I expect, and if someone's not interested, it's better for us to do earlier separation. But also, again, this is like, there's no way I would have been able to ramp or be able to do code, because my time is, there's just a lot of context switching without Claude. And so for those of you in the room who are managers, I really, encourage y'all to kind of like lean in. I'll be honest, for a long time at Meta, I would still try every year to do one PR a year, but the code, the workflows would always change. Like all the internal tools, like by the time I learned one command, it would have changed. Nowadays, I don't even remember Git commands. I just always ask Claude to help me out with all of that. Knowledge sharing, what becomes your new source of truth? So for example, on our team, on Claude Code, the code is a source of truth. That's why I would go back to when I'm like answering customer requests, I just have my desktop Claude Code, and then I have all my, local repositories to actually answer a lot of customer questions. So for us, just having that code base be the source of truth also like prevents some of the lag that you might have had before of how to keep up the documentation, correct with the code. But I would say this is where it's like do what makes sense for your team. So for example, if you still have a lot of really good specs, check those into the repositories and then have Claude lean in to help, hey, take a look at how verify my code execution still matches what I expect on the spec. And so how did we roll it out? Because these were, I had just gone through some of the norms that we had changed. And I think it's interesting, there's a blend of what do we kind of mandate as team norms? Like make sure you're gaining alignment with the team. And then where do I really enable each, we have pods within Claude Code. Want to make sure I enable each pod to do what makes sense for them as well. So in terms of the balance, in terms of forcing function, it's aligned with the teams on the must-dos. So these are a few of the core Claude Code team principles that we really live and breathe. And by the way, if you remember, again, I'll go back to that growth mindset and always think about is something still serving you. We keep these up to date. So every few months, we'll be like, hey, is this still having the same effect or serving the purpose that we wanted when we started it? So for example, and I should replace this slide, it's not every engineer uses Claude Code. That's obvious. It's actually every Claude Code team member, including cross-functional partners. And actually, we all use CoWork quite a bit too. Claudify everything you can. This is one thing where we're like, what's better than one of us doing it? Having Claude. So always think about, is there some way for you to automate, whether it's verification, more shift left, but always be thinking, what you're doing something right now, is there some way that Claude could actually help you do it? And the last one's my favorite, explicit permission to kill those processes. Because again, processes will kill themselves. But as you're supporting teams, it's really important to always get that fast feedback for your team of what are the things that, we're spending a lot of, I remember when I first joined Claude Code, we used to do stand-ups. And then the team got a little bit big, so then we had a spreadsheet. We would all put up our, weekly progress. And then all of a sudden we're like, oh wait, we should just do a skill, right? Like a stand-up script, so then we can just run Claude, and all of us can always be much more kept aware of what everybody else is doing. So that's just an example of one day I remember looking at the spreadsheet going, wait, does this still make sense anymore? So always question and always look to defrag and kill old processes. What I want to make sure that I leave a lot of room for pods to adapt. It's for each team really has a lot of high agency for how they do triage or leverage Claude to do triage, any planning rituals or stand-ups, how they think about on-calls, and also which workflows to Claudify first. So we don't usually mandate thou shalt automate this. We have some suggestions and learnings, but always give room to your team, especially they may be touching on different problem areas. So if I zoom out, what were the 3 things I prioritized on, when I joined Claude Code that I felt has made the biggest difference? Keeping the team as flat as possible. Managers really support pods of work, but really keep it agile. So for example, on Claude Code and CoWork, we have one overall team mission. Because sometimes when you start creating pods, each pod then wants maybe to set up their own mission, and then anytime you have to shift, it might take a lot of time to walk people through that. But it's really as flat as you can. I felt that served us really well. The Claudify everything better than you doing it. See how Claude can help you. It really frees us up to do more of the harder work. And again, the processes, they do pile on. So I encourage you to kind of work with your team to see what are the processes that actually you should be able to let go. So does it actually work? I can't go into the explicit numbers, but I think these are 3 general kind of metrics that you can look at as you're rolling out changes on your team that might start steering you to, yeah, this seems like it's kind of starting to be successful. The onboarding ramp-up time, that has dramatically reduced. So that's an interesting thing of like how soon an engineer or a designer or like a PM can start being effective on your team. The PR cycle time shortening. I think this one's interesting to double click into a bit because it might actually help you identify a gap that's not just in terms of lack of AI adoption, but where the rest of the pipeline might be struggling to scale. So for example, again, as we're now like, just putting in through so much more code, sometimes the product infrastructure can build on CI, still keep up with the amount that engineers are checking in. So both of those should go down, but then what should go up a little bit is Claude assisted commits. For example, for us, it's by default, every commit is Claude assisted. I don't think I've seen a non-Claude assisted commit probably in the last 4 months or so. But hopefully these 3 things are kind of like metrics that you can kind of take a look at your team and see how it resonates. I would also say though, outside of just the number of commits, also think about the end goal. Like if you zoom out, what is the product that you're trying to make more delightful for users? Or what is the problem you're trying to solve? Because sometimes you see it on all the headlines of this company said X% of code is now generated by AI. I think throughput is great, but really think about how you measure what it is that you're actually really trying to solve. Like for example, we really want to make sure we're keeping an eye on quality and reliability. So those are some of the things that we're paying more attention to as well. Okay, so my last section is to audit your own efforts. I'll share with you transparently, actually, I still have a couple of questions that I am still asking myself. The iOS and Android org is a very interesting one. Like when engineers can now more efficiently kind of flex across different mobile platforms, does a more traditional way of having an iOS team and an Android team still make sense? That's something that I'm still kind of thinking through. How much do you push that fully automated review? Again, like when do you kind of strike that balance between fast enough and we lost something important? It goes back to the trust but verify. And what's interesting is you even might have heard today and earlier Dara and Danella's talk, the model capabilities do keep improving. So also, even if you might need to do more verify than trust for a certain section of work, that might also change with the next model. So that's why it's always important to reevaluate. And roles are blurring, so how do you make sure that everybody feels equally productive? So if I were to leave you with one thing to take back of is, pick your noisiest workflow. And by noisiest workflow, it could be most expensive, what's something that, you yourself might be dreading or even your team might not really look forward to it. And ask, is it still really serving what's the purpose of there? Like, actually, I'll share another funny story. There was a team I was on where we used to have this weekly review. It's a very expensive review, like 50 people, in this large room. And then I noticed everybody's on their laptops, except for when it's their time to give status report. And then they pop their head up, say the status, and then go back down. And I'm like, this is a very expensive meeting. And I just asked that simple question of, why are we having it? And just that one question, everybody's like, yeah, it's true. And so we canceled it. So that's why it's always important to think. And so, yeah, like I figured this might be something fun for you to take back and look and see what's one piece of workflow that you might consider, can you either automate or maybe even is it still, is it still serving its intended purpose? So with that, that's the end of our talk. I'm like, 3 minutes. Thank you. Thanks a lot for attending. I really for sure thought this room was going to be empty, so thanks for not having me by myself. And I'm around here today and tomorrow, so if you have any questions or want to chat more, feel free to introduce yourself and happy to chat.